What's that again? Do you know the names that door? There was some staff member.
Here we go. Okay, we managed to figure it out, thankfully, figure out all the AV stuff. Once again, if you're here for the first AI program, Serverless WebAssembly, you're in the right room. And sorry for the delays. Let's jump right in. So just, I guess, before we jump in, we should maybe say who we are. My name's Caleb Shep. I'm a software engineer at Fermyon. I've been there for about a year. Work on the Fermyon cloud and some of the upstream open source stuff like Spin, which we'll be playing around with today, and SpinCube too.
I'm Justin Pfluger. I also work at Fermyon. I'm a solutions engineer, so I engineer solutions. And yeah, work with Fermyon customers to kind of build out applications and kind of take advantage of WebAssembly on the server.
Awesome. So I want to start by talking about what you guys are going to be walking away with today. And really kind of the meat of it is some hands-on experience with WebAssembly. So we're going to be getting our hands dirty there and actually playing around with WebAssembly on the server side. And specifically, we'll be using the open source tool Spin, which you'll learn more about in a second. And we'll be learning things about like how to route requests into your Spin application, kind of all the features you can use in a Spin app like KV stores or generative AI models, those large language models. And then we're also going to be like running these locally and deploying to Fermyon Cloud and kind of experiencing that full gamut there. Just kind of a quick agenda for today. We're going to spend the first kind of like 15 to 20 minutes just talking about a few things here. We'll do kind of a 101 level introduction to WebAssembly and kind of a 101 level introduction to Spin. Give everybody here some context on that. Then we'll do a brief overview of what the workshop's going to look like. And then the majority of the time is just going to be kind of a live coded walkthrough of the workshop, and we'll go through a step.
Quick show of hands. Who's heard of or used WebAssembly before? Got a couple. Anybody Fermyon fans, Spin fans out there? All right, well, we'll make some new ones. Hey,
awesome.
We got
one
one
in the
back
back
there.
Okay,
Sweet.
Cool. New crowd to evangelize to. Awesome. So we'll jump right in here. Now, I just want to give an opportunity here at the start. We've got 3 ways we can kind of work through this workshop. The first way is you can install the dependencies locally and do it that way. Second way is you can go to our workshop, our github.com Fermyon workshops, download that and use a dev container. Or kind of the way we recommend that people work through this is using a VS Code code space. So if you go to this URL using the QR code there, you can click on code, clone, and then go to the code spaces tab and generate a code space. It's a full editor online. It will have all the dependencies for you to kind of work on out of the box. So I'll give maybe a couple more seconds in case anybody wants to scan that and get that going, but we'll walk through that later.
And if anybody gets stuck or has questions, just raise your hand. I'll come around and help you. There was a little mix-up with the venue today. There were supposed to be tables and stuff for you to get out your laptops and set them out, but yeah, we just have chairs today. So
we'll make do. We'll make do. Okay, I don't see any more scanning of the QR code there. So we already did this poll. Awesome. Okay, so starting with kind of like a 101 on WebAssembly. What are the 3 most important things we should like know about WebAssembly? Well, first of all, WebAssembly is a specification. And more specifically, WebAssembly is a specification of a binary instruction format. So really what you should think of WebAssembly as is it's a compile target. You can take your source code in Rust or TypeScript or Go or whatever language that supports WebAssembly and compile that into this WebAssembly instruction format and then execute that later. And also, we should know that WASM is an abbreviation of WebAssembly. You're going to hear me say WASM and WebAssembly interchangeably. You're going to see it interchangeably on the slides and everywhere, so that's a good thing to keep in mind. Here's kind of just like a visual of what this means, right? You've got your code. You, for example, maybe use your Rust compiler to compile it to a WebAssembly module. And then that module can be executed by a WebAssembly runtime, which could be running in a container. It could be running locally. It could be running in the cloud on an IoT device. Now, whenever I talk publicly about WebAssembly, I always like to kind of come back to 4 reasons why you should care about WebAssembly. Because it's like, sure, it's this cool new tech and there's a bunch of hype about it, but like, why does it matter? And I think there's 4 reasons. First reason is security. And so WebAssembly offers us a sandboxed execution environment. And in addition to that, it also offers us something called capabilities-based security. So what do I mean by sandboxed execution environment? What I mean by that is that when a runtime is executing WebAssembly, it's called a guest module, it's sandboxed, it's secure, and there's guarantees in the WebAssembly runtime that the code's never going to be able to break out of that sandbox. It's not going to be able to do a buffer overflow or any sort of attack like that and attack the underlying device that's executing that WebAssembly. We're also going to hear a bit more later about capabilities-based security, which is basically saying you have to explicitly require access to things on the system, and then you can audit those capabilities you're requesting. The second reason I think we should care about WebAssembly is performance. And really, performance is just kind of table stakes, I think. We're not going to see adoption of WebAssembly without performance. Third, WebAssembly is polyglot. And what does that mean? Poly, many, glot languages means that WebAssembly supports a wide array of languages. So you can take a Python program or a Rust program or any number of languages and all compile them to WebAssembly and have them cooperate together nicely. And then fourth, WebAssembly offers like a great portability story. Similar to Java, where you compile it to that bytecode, and then anywhere you have a runtime for that Java bytecode, you can run it, that sort of write once, run anywhere story. Similar thing in WebAssembly. You have a runtime for all the different systems and architectures you want to run on, and you get great portability out of that WebAssembly code. When we talk about WebAssembly, you're also going to hear something called WASI come up a lot. And WASI stands for WebAssembly System Interface. And to understand what WASI is and why it matters, I think it's important to think about the history of WebAssembly. And so WebAssembly originated as a technology for the browser to bring non-JavaScript code into the browser. But that meant it was really tied to JavaScript and web APIs, things like the DOM and such. And so as there's kind of this movement to bring WebAssembly to the server side, there arose this need to have access to things on your system, like the file system or environment variables or other things like that. And so WASI is really a specification around how do we standardize these imports into a WebAssembly module so that it can access these things on the system and behave more like a POSIX program. And really, WASI is continuing that story of portability, standardizing what it means to interact with a file system, whether you're on a POSIX system or a Windows system or whatever, and also that security through capabilities-based security. You have to explicitly request access to the file system, and then you can audit whether you want the code to have access to that. Again, coming back to this polyglot story, WebAssembly has great support across a wide array of languages. On our developer site, we have a table tracking that, and this is really just growing. It's amazing how fast support is landing for WebAssembly across languages. Now, we talked a bit about performance. Originally, WebAssembly was meant to be executed in these JavaScript runtime engines, V8, SpiderMonkey, those kind of things. And that's, of course, because WebAssembly originated in browser. That was the kind of original context. But again, as this kind of like push to the server side for WebAssembly, we found a need for new runtimes. And so that's kind of where we get these WASI runtimes, such as WASM-Time or WASM-3, things like that. And these are really kind of meant to be used in more like functions as a service use cases or like IoT and things like that. Not for this talk, but I think it's really cool to point out there's like some crazy engineering here to get this kind of like near native execution speed. So it's a really cool space. So, we've talked about those 4 things that make WebAssembly great. What are some good use cases for WebAssembly, obviously outside of the browser? 3 kind of come to mind. First is cloud and functions as a service. So why is that a good fit for WebAssembly? Well, you think about what you're doing in functions as a service. You're executing arbitrary code from some customer. So you want it to be secure. You want it to be sandboxed so you can safely execute their code. You want it to be performant. So you need near native execution speed. And you need it to have really low cold start times and be cheap to ship around. So you want small binary sizes, which WebAssembly gives you. So that's a great fit for WebAssembly. And we'll be getting a lot more into that because that's really kind of what Spin offers, is that sort of functions as a service paradigm. The second one here is plugins. Again, coming back to the security, being able to trust arbitrary code in those small sizes makes it a great fit for plugin architectures. I forget the exact quote, but our CEO always likes to quote basically that WebAssembly is the last plugin architecture you'll ever need, because we'll support all the languages, right, that kind of polyglot nature, and be able to compile anything down to WebAssembly for a plugin. And then third, IoT is, of course, like a great use case. We don't really focus on it much at Fermyon, but again, the security, the performance, the small binary sizes, all are great reasons to use WebAssembly in the IoT space. Sweet. So that's kind of like the whirlwind tour of WebAssembly. That should be like a 4-hour talk, but we compressed it into 5. Now we're going to talk about Spin. And so what is Spin? Well, WebAssembly is great. We talked about all these things, reasons we like it. But it's like super new, and the developer experience is like really rough around the edge. And so Spin is really the developer tool for kind of building these serverless WASM applications super easy. So we started this about 2 years, is that right, Justin, at Fermyon? 2 years ago?
Yeah, 2 years and change.
2 years and change. And so here's kind of like an overview of what using Spin looks like. And there's kind of really 3 marquee commands in Spin. So the first one is spin new. And spin new is basically how you go from like a blinking cursor to having an application in front of you. And so, today we will be going through in TypeScript, and you want to build your TypeScript serverless WebAssembly application. You'd go spin new, and that will scaffold out a TypeScript application for you that you can then write your code into. And it will also build a manifest, which we'll be looking at later, which kind of describes how do I compile my application to WebAssembly, what capabilities do I want to have access to, all those kinds of things. Once you've hit spin new and you've spent some time developing your code, then you need to compile it down to WebAssembly, and that's where spin build comes in. And spin build, the command, basically just abstracts away all the complexity of compiling your code down to WebAssembly. Then once you've spin built, you have your compiled WebAssembly application, then you can run spin up for a local testing experience, which will serve your application. You can test it locally. You could deploy it to Fermyon Cloud, which we'll talk about in a second. You could deploy it to a Kubernetes cluster. You could really anywhere you can run Spin, you could run that Spin application. Spin has many features. We'll be seeing a lot of them today. It has support for serverless AI, which is going to play largely into our demo today. Support for things like key value stores and databases, relational databases, config, and we even support multiple types of triggers. So you can trigger your Spin application like a web server with an HTTP trigger. So you hit a route and your application is triggered, or you can set it up for triggers like Redis. So a message is published to a channel on Redis, and you trigger your application to process some of that data, or MQTT. I mean, the possibility for triggers is really kind of endless in Spin. Just as a brief aside, I kind of want to point out on the developer.fermyon.com site, we have a Spin Up Hub, which after this, if you want to check out more about Spin and kind of like see examples of things people have built, that's a great place to go. Okay, so I alluded to this earlier. Fermyon Cloud is basically our opinionated hosting solution for Spin apps. So if you want to run your Spin app in production, you can, of course, just spin up a VM or a container and run Spin up, or use our new project we just released, SpinCube. But Fermyon Cloud, we view as kind of the easiest way to get going. It's literally just spin cloud deploy, and you've got your WebAssembly application running in the cloud. And it also offers some really cool opportunities with serverless AI that I want to talk about. So we'll get into this more once we start working through the workshop here real soon. But we're going to have an application, and it's going to be accessing a Llama 2 chat, generative AI model. And that's pretty straightforward. That's great. Makes it easy to hook your function up to that and use that. But let's think about what that means when you deploy this WebAssembly function to the cloud, and you want to run that. And you could also kind of compare this to using AI in Lambda. It's great. You've got a request coming into your Lambda or your Spin function, but that starts up really quick because all the benefits of WebAssembly. But what if you have to spin up a GPU every single time you want to access that generative AI model? That's obviously not going to be very fast. And so within Fermyon Cloud, we've built this system where we're able to multiplex all the GPU usage from all these different Spin apps in the cloud to our own pool of GPUs in the back end. And so what that gives us is really kind of 2 key things. One, it gives you really low cold start times, because no longer is a request coming into your app and then you need to spin up a GPU and wait for that. You just have an already warmed up GPU in the back end running. But 2, it also keeps your costs down, because the only GPU time you're really paying for is the actual inferencing of that. So here's kind of an example of what an application doing that might look like. And this is kind of similar to the application we'll have by the end of the day, where that blue line, you have a inference request coming into your Spin application, and it's using these large language models, which are like pooled in the back background for really low cold start times. And then you can use key value stores to cache the responses or put context embeddings into a SQLite database and do all those kinds of things. I'll just breeze by this for now. I think that will all kind of add up a bit more at the end once we've done it.
Fun fact here, Fermyon Cloud so our GPU pool is built on Civo and Green Cloud. So every time you inference today, you'll be warming a pool somewhere in London.
Yep.
Fun fact.
I like that one. Okay, so it's time for the workshop. Let's get hands-on. Enough talking. Today we're going to be doing a Magic 8-Ball workshop. And I don't know if any of you ever played with Magic 8-Balls growing up. I certainly did not. I had to Google what they are. But for the uninitiated, a Magic 8-Ball is a ball that you come to and you can shake it, and then it will come up with an answer to your question. So you might come up to the Magic 8-Ball and say, am I going to have a good day today? And you would shake the Magic 8-Ball, and it would magically come up with an answer and say, the answer is unclear. Not very helpful, but maybe fun. Fun fact, I learned this while I was Wikipediaing Magic 8-Balls. It's actually just a D20 that's floating in some fluid, and when you shake it, it just floats up to the top. So cool, pretty cool technology. Okay, so we're going to be building a spin app that's replicating this kind of Magic 8-Ball experience, and we're going to be not only generating these answers, but we're going to be generating them with AI, so that's how we're using the generative model. And then we're also going to be using the key value store to cache those responses. Here's kind of the steps of the workshop. So we're going to start with setup, which is kind of just installing Spin or setting up your code space to get going there. And then we're going to do getting started, kind of play around with the hello world experience. Then we'll roll that into something a bit more useful, build a JSON API that will respond with that Magic 8 response, just kind of with random answers. We'll augment that then and use the LLM model to actually generate those answers. And then we'll put a pretty front end on it, so we have kind of a nice user experience around that. And then we'll cache those values with the key value store. I think that'll probably take most of our time, but depending on how things go, we have a bit of an extra exercise.
Yeah, the extra exercise is going to be kind of a choose-your-own-adventure. We haven't finished all the code for it, so yeah.
Okay, so here's a QR code, and that should take you to the workshops. So yeah, like we said earlier, unfortunately, there was a bit of a mix-up, and we weren't set up with tables today. But I encourage you to pull out the laptop on your lap and kind of work through it here. I'll switch my screen in a second here once people have a chance to go for the QR code. There's 3 ways we're kind of supporting this workshop again, which is locally, basically installing the dependencies directly on your machine. You can clone the workshops directory and use the dev container through like VS Code. Or my personal recommendation is just go to GitHub and set up a code space where it'll spin up that dev container remote for you, and then all the dependencies will just work and you can do it out of your browser.
And if you get stuck at any time, just raise your hand and I'll come around and help.
Oh, password for Wi-Fi? Penguins, yes. Fast or slow, I'm not sure which network to choose. I was thinking it was maybe the game. Okay. One's 5 gigahertz, I've learned, and one's 2.5. Okay, so seems like everybody's got that QR code scanned. I will head over to the workshop. Okay, and we'll just give a bit of time at the start here because the installation process might be a little bit slow on the Wi-Fi, perhaps. Seems like my Wi-Fi is a little bit slow. Very slow. Well, I might have to change to do it locally if it doesn't load. So I guess I'll just do that to show people for a second. Come on. Okay, so we're going to start with setup. And there's really, as I said, 3 paths. The code spaces should be pretty straightforward. Just raise your hand if you can't figure out how to start that. And then maybe the least straightforward one is just configuring your local environment. So for anybody using Linux, WSL2 on Windows, or Mac OS, you can go ahead and install Spin by using our brew tap. And then we can go ahead and install some templates. Those aren't directly necessary for this tutorial, but they'll be handy for later. And we'll just give a couple more minutes here. Oh, yeah. Whoa. Font size. Why terminal? Does that work? There we go. Can people see that fine in the back? Yes, go ahead. So if you click like clone, the green one, and then there should be a code spaces tab. And it will take a second to generate the code space because it builds a container, but. Just fine. Oh, okay, perfect. Let's do. Awesome. So by a show of hands, can I see who's still working on getting a code space running or installing things? Okay, still going. I know.
While other folks are getting set up, did we have any questions about WebAssembly, Spin, or anything from the first portion of the talk? Cool. Perfect comprehension. Great job.
Yes. Go ahead.
The question was, what languages does Spin support? So it's a good question. So we have kind of tiers of languages that Spin supports right now. Tier 1 languages is what we call like languages that have support for generated bindings for our SDK. So going back to what Caleb was talking about before, the WASI spec is built on top of this additional spec called WIT, which is WebAssembly interface types. And that's how we describe external kind of interactions from WebAssembly. So that's kind of how we express the Spin SDK. And there's five-ish languages. Depends if you include TypeScript as an additional language on top of JavaScript. But 4 or 5 languages right now that we would call Tier 1 support. And then probably 10-ish languages that we would call Tier 2 that compile to WebAssembly, but you don't have access to the Spin SDK because they're still building out support in WIT to kind of generate those bindings for the SDK. But you can still use those languages kind of like a CGI script, essentially. So standard in would be your request, your like kind of raw HTTP request, and then standard out would be your response. Yeah.
Just for people who walked in, we're just starting to set up and install Spin. There's 3 ways we can do it. There's a code spaces on the workshops where you can spin that up online. People might be having trouble with that. I can't get my code space to load, so I'm not quite sure how the internet's working for other people. And so maybe locally might be a better solution too. And we have steps in the workshop setup page for doing it locally. Just need to install Spin from our brew tap. Awesome, and I'll just do another show of hands. Who's still working on setting up the Spin environment? Couple people, okay. We'll give it like a few more minutes and then we'll just jump in here and do the demo and we'll just make sure you guys are tracking through. We don't have sample apps for Python prepared. You can take a crack at it. It should, all the SDKs are there and work. But we'll be going through TypeScript here, and any sample apps are all in TypeScript or Rust. Okay, I think we probably have close enough, and if people fall behind, just raise your hand and we'll make sure to come around and get you caught up and get Spin running. But I want to dive in and start talking about this here. Okay, so we're all set up. Let's go to getting started. Awesome. So, you know, we can all start by running Spin version, make sure we've got Spin running on our machine. And as I said, there's kind of this flow of Spin new, Spin build, and then Spin up. So we're just going to see what that looks like, just kind of locally here. So I'm going to be doing TypeScript up here at the front. So I want to build a new application, and I'm just going to do this in this directory here. So I'll do Spin new, and then I'm going to pass the application of the name. I'm going to say hello TypeScript as the name of my application. And then I'm going to use a template called HTTP TypeScript. So this is going to start kind of a scaffolding command. It's going to ask for a description of my application. So I'll give it a description, and I'll say something along the lines of hello world app. And then it's going to ask for a path. And so by default, this will make more sense later when we see the manifest, but by default, we're going to be using an HTTP trigger, which means it's HTTP requests coming in that are going to trigger your component. And so path is saying, what path should I allow to come into the component? What mapping of paths? And so we're just going to stick with the default here, which is just saying any path can come into this component, and we'll support that. Awesome. So I should see a hello TypeScript folder now, and I can navigate into that. Yes. Is that big enough for everybody in the back? I see some leaning forward, so I take that as a no. How's that? I see a thumbs up. Cool. Awesome. Okay, so we're in the directory here, and we'll just do a tree to see what we've got scaffolded out for us. We got a README, and then we've got kind of all the accoutrements you would expect of a typical TypeScript project. So you've got your package.json for your dependencies, and you've got your source directory with an index.TypeScript file and all that kind of stuff. So let's maybe start by looking at the TypeScript file here and see what that looks like. Okay, so it's really simple. We're just exporting a handle request function, and that handle request function takes in a request and returns a async response. And we're not doing anything fancy in here. We're just returning a 200 status code, text plain content type, and hello from TS SDK as the type. Now we've got the package.json, just like you would expect with a JavaScript project here. And you can see that we're importing the Fermyon Spin SDK. And this is what allows us to use these kind of custom HTTP request and response types. Now, kind of where the real meat on the bone comes from is the manifest I keep talking about. And that's the spin.toml. So here we've got a spin.toml. So this is configuring a number of things about your Spin application. In that application section, it's just kind of metadata, who's the author, what's the description of this app, what version, all that kind of stuff, the name of your app. But the really important part is the trigger.http section and then that component section. So the trigger part is saying, I have an HTTP trigger, and I want to take anything coming in on the route /.. which is meaning any possible route, and I want to map that to my hello TypeScript component, which I have defined below. So then I have my hello TypeScript component, and this is what's taking that source code we have in that source.ts file and saying, okay, you need to run this command to build this JavaScript into WebAssembly, and then this is the underlying WebAssembly that should be used to run that component. Now, there's a bunch of magic in the package.json build scripts that actually does the work of compiling to WebAssembly, but that's the beauty of Spin, that it's scaffolded for you, and then you just don't have to worry about all that compilation process. Great, so we've got the application here. Is there anything else I want to show you? No, so that's it. So now we want to build this application, so we can go spin build. And this is actually going to fail because I forgot the first step in a, here, I'll just kill it. In a TypeScript application, we first need to install the dependencies. So I'll npm install those dependencies. If I had thought about it, I probably would have done that earlier, pending on conference Wi-Fi. We'll see how that goes. And so this is going to install the dependencies for the app. And then we'll be able to run spin build, which will compile it to WebAssembly. Any questions on that so far? Wow, that's some slow internet. I think I chose fast. Slow was pretty fast. Okay, I'll have to try that one out. Okay, we're switching to the backup plan because that's being slow, and I'm going to use Rust because that does not need to install a bunch of dependencies slowly. So I'll just do these steps quick. Hello Rust, template, HTTP Rust. We'll skip the description for now. And this is going to have all the same things. The spin.toml is going to look slightly different with a different build command, but same kind of underlying thing. So we'll run spin build, and that's going to build our app here. Oh, that needs to update create indexes too. Awesome. So now we've built the Spin app. And for Rust, that's going to live under target WASM32. Might be release, actually. Nope. So you can see we've got that hello rust.wasm file there. Now if we go spin up, it's going to take our built application. It knows from the manifest where to look for that WebAssembly file. Let me just make this a bit bigger. And we can see that we've now got our app running. And so if I just go ahead and copy paste this, and then in a new terminal, if I curl that endpoint, we see hello Fermion responding back to us. Awesome. Now, just as kind of a demonstration, we can hop in here and edit the source and say, hello WebAssembly, and rebuild that application because we need to recompile that WebAssembly to use that new hello WebAssembly string. Run spin up again, and recurl that endpoint. We should see hello WebAssembly. Awesome. Socket timeout on the npmi. Okay, well maybe we'll see how doing TypeScript up here at the front is. Awesome, so that's getting started. That's what scaffolding an app in Spin looks like. How are we doing? Any questions? Anybody stuck, not making it through that part? Go ahead.
So this is kind of off a little bit of the topic, but if you've got an application written, say, in Python and Java, do we compile each one of those and then combine them together into what I would consider the final build?
Yes, yeah,
Okay.
absolutely.
And then if you've got, unfortunately, low-level C functions that are talking to an IoT, how do you have to obviously build a WebAssembly API for that? Is that kind of how you do the IoT deployment stuff when you're trying to look at board-specific systems?
Yeah, go ahead, Justin.
Yeah, so you would need to kind of use WIT and the WASI spec to kind of poke a hole from the WebAssembly guest into the host to be able to access that hardware device.
Okay.
And that can kind of be your own kind of interface, whatever you want to create that. And then you can use like Zig compiles to WebAssembly.
Okay.
So
I just kind of want to know the basics. I don't want to like freak out.
yeah, no worries.
Yeah.
That's part of the component model. That's something that just got WASI 02 just got finalized. Let's see, January, I think.
That sounds right, yeah.
Yeah.
And I mean, to put it another way, Spin does as much as possible to hide WebAssembly in a lot of ways. Like, you should not even really have to think about it. But all the configurations and options are there to do all the plumbing you want and run your C with your special APIs and all that stuff under the hood.
I do some work in an oil refinery, and they have lots of sensors that don't support, it's all serial connection. So we have a big ass MUX that we talk to that abstracts it. So it's kind of painful. I'm just trying to figure out how I can make it easier.
Right.
Totally.
Another way you could do it is, since Spin is like all open source, you can create your custom triggers. So we have a lot of like community contributed triggers. So say you wanted to run some piece of WebAssembly based off of some hardware event, you can write your own thing in like C or Rust.
Just get the hardware to send a signal, an event into the system. Okay.
Yep. Yeah.
Awesome. So for anybody who just came in, we're just going through the workshop flow here. It's just at github.com, Fermion Workshops. You can set it up locally or in a code space and just raise your hand if you need to get caught up. Great, so we've demonstrated that kind of getting started flow. Let's move on to the next step here and build ourselves a JSON API. So what we want to do is we just want to build something really simple that takes in a question and returns just a random answer from these 4 examples, and then we'll spice that up later. So again, we'll kind of use the process of spin new, scaffolding out an application, and then we're going to build it with some of this fancier code. So let's just get going on that. So first, I'll kill this hello world TypeScript I had. Then I want to do spin new magic 8 ball TS. And we're just going to use the HTTP TypeScript template again, a magic 8-ball application. And this time, we're going to use a specific path, and we're going to say, only take in requests to the magic 8 path. Oh, yes, thank you. /magic 8. Awesome. So now we've got our magic 8-ball application here. Similar thing. This time I'm going to learn my lesson in npm install while I'm coding, so it's hopefully done. Awesome. So we've got a similar handle of requests function this time, except instead of just like directly returning a response, we actually want to use a question that's coming in from the request. And so how we're going to do that, or sorry, I'm getting ahead of myself. We're not even going to use the question yet. We're just directly returning a random answer. And so, pretty straightforward stuff here, just a normal JavaScript function that is taking in an answer, and I can dump that directly into my application. Oops. And then we can also see we are, whoops, sorry folks, we're directly using that response instead of returning this 200. Awesome. We're getting a red error here because we haven't npm installed yet. That's okay, that'll go away. And we will wait again. Looks like it's making progress though. And thankfully, this will be the last time we'll have to npm install for this app. Awesome. Okay, now I can spin build the app. That's compiling the WebAssembly using Webpack to do all the bindings and such. And then I can run spin up. Awesome, we've got it going. If I curl it, we get no response as expected because we're not hitting the magic 8 endpoint. So it's not routing through to our component. But if we add the appropriate magic 8, we'll see some JSON response. Pipe that through to JQ. Awesome. And we'll see that it's randomly returning a response. So, this is obviously like really, really simplistic, but it kind of gives you an idea of how you might structure sort of a simple backend API out of a spin application and have different routes running to different components for your different services or whatever. You can obviously crank the complexity up from there. Anything else we want to hit here, Justin? I don't think so. Any questions? Yes?
So I'm having some code spaces issues where I can build and spin up the application, but I can't see the endpoints.
Yeah, so we're hearing a question about some code space issues. We'll help out with that. It's likely, so Codespaces does this kind of fancy port forwarding stuff, which can sometimes cause issues. So we'll help out there. Awesome. Okay, so we got a JSON API. Now it's time to kind of make this a little bit more fancy and use the AI. Go ahead. That's a great question. Let's go see. So I need to see where the WASM file is living, and the WASM file is living under target. Target. Get some human sizes. So 2 megs. And go ahead. Yeah. Yeah. Yeah, and you're saying specifically using different languages within Spin. Sure. The short answer is no. They're typically going to be similar, but the way that different languages support WebAssembly is going to result in pretty different WebAssembly binaries. So just as a brief example, Python, the way we support that dynamic language is we actually bundle in the Python interpreter compiled to WebAssembly, which is going to increase the size. That's a whole other conversation of in the future we'll be able to link that out and things like that, but it will be different. I saw a question there.
I was going to ask a question about if that binary is compiled
correct?
That probably what adds up to the almost 2.5 minutes, right?
Correct. Yeah, just to repeat the question, he's saying that all the dependencies you've compiled into that is going to add to the size of that.
Yeah, and actually your node modules won't be included in the WASM file. What takes up a decent chunk of this is the JavaScript interpreter. So,
Okay, so it's the interpreter.
yeah. Yeah, so our current, the JavaScript SDK you use today is actually built on top of our Rust SDK, and it uses a project called Javi, which I think is built on top of the QuickJS interpreter. So we take all of that, compile it into Rust, and then we use that, our Rust SDK to actually invoke the interpreter and load up your JavaScript. But then Webpack should strip out most of the node modules that aren't used. Yeah.
Like do the tree shaping and everything.
Yeah.
Totally.
So if you're looking for a small deployment, what language should you be using as the original?
Smallest, probably, smallest with the best support would be Rust. There's also quite a few like community contributed things around Zig and C++ as well. That should all work.
Awesome. Okay, so now we're going to really kind of dive into the meat of this and start using the generative AI model, specifically Llama 2 chat model, to generate these responses. So the way we make this easy is we have an SDK written around this that you can use in your Rust or JavaScript application to access that LLM model. And so what we're going to do here is we need to modify our request handler to take in the question like I was talking about earlier from the request. So we want to take in that request body, decode it, use that value as our data. Then we want to pass that data into a prompt that will pass off to the chat model, and then that will generate the answer to a question. I'll hand it off to Justin for a second to kind of talk about the prompt, the Llama 2 chat prompt, and how that all works.
Yeah, so as you can see, there's some like specific formatting in here. If you've never used Llama before, these are just instructions that Llama understands to kind of differentiate between what like you want the text generation to use as context. So that's this kind of sys with the brackets around it or the arrows around it. So this portion of the prompt will be interpreted by Llama as contextual information for how to answer the question. And then everything after sys up until the end of this instruction will be interpreted as this is the question or thing that I need to actually generate text for.
Any questions about that before I throw that into the application there? Okay. Okay, so let's start by pulling this question out of the response body here. We will pull up our source code. So we want to pull the question out here, and we need to get some decoders. Let's go like this. So these are just kind of helpers, basically, to do the bytes to string mapping that we need to do in JavaScript. This isn't a requirement in other things like Rust SDKs. Great, so we've got this encoder and decoder now, and we're going to decode the question out of there, return an error if no question was asked. Now we need to change our answer function to not just be randomly returning something, so let's just remove that for now. But instead, we want to do this more exciting thing and use the LLM here. Great. Okay, so we're going to see some errors. That's expected. That's because we're not importing these types from the SDK. No need to import anything extra from the package JSON. It's all coming out of the Spin SDK package. And we'll fix the one last error, and we'll pass in the question that we've parsed out of the body into the answer generator here. Great, that looks like it's going to compile. I'll come over here. We'll run spin build again.
Did you want to show him spin watch since
Yeah.
you built it?
Funny, yeah. So it would be amazing to think about how many times I forget to run spin build, and so I got tired of that, and I built a spin watch command. And spin watch is just basically going to watch for any changes to your source code, just kind of like any other npm watch command, and automatically run build for you, and then directly run up. Great, so we've already got up running. Now, we're going to run this, and there's going to be an error, and let's see why that is. Well, the first obvious error that I forgot about is we didn't pass any data to it, so that's doing its job, so let's pass the question to it. Is this demo going to work? Will be my question. Okay, we got the error like expected. Now remember back in my presentation when I talked about the security of WebAssembly and the capabilities-based security? This is where this comes in. So in order to be able to use this AI model that we want to use, we need to explicitly request the capability to access that model. So we can see this error here. The component does not have access to the Llama 2 chat model. So let's give it access to that. And the way you do that is by adding that to the manifest. So we go back to our application and we go to our spin.toml, our application manifest. Here in the component section, we need to say, hey, this specific component has access to a model called Llama 2 chat. So we should have seen this rebuild there. And then we can rerun it. And we're going to see another error. Perfect. Oh, the error is because I didn't run it. There we go. OK, another error is expected. So now it's failing because for local development, we expect that it has a Llama 2 chat model locally in your .spin/AI models directory. Now, I have it downloaded locally, and so I'll be able to show that to you. Unfortunately, it's pretty massive. It's like 8 gigs or something like that, and so it's kind of untenable for us to all download an 8 gig model on conference Wi-Fi here. But I can demonstrate this, and then I'll be able to show you in a second how you guys will be able to run it the 2 different ways. So if I just make a directory .spin here, and file exists. Oh, OK. And then if I just link, I have it just stored in one location on my laptop, so I don't have to copy the model around everywhere. And I link an AI models directory here. Perfect. Then I should just be able to run spin up again, because it will be looking at runtime. OK, it's running. Now, the one other reason we might not want to use models here locally is because I'm grinding away this giant Llama 2 chat model on my MacBook. And so this is going to take about a minute to run, which is obviously not great for demo purposes. But it kind of paints to this story of being able to at least use it locally, and you can do workarounds like running smaller models with smaller parameter sizes.
Yeah, by default, it will use a quantized model to execute on CPU locally. If you wanted to take advantage of GPU execution while running locally, you would have to clone spin and then do a cargo build with the feature enabled. But it is possible. It's just not enabled by default because it massively increases the size of spin CLI.
So while that's chugging away, oh, yes, question.
Just a boring question. I could get the decoder. Something's missing in the code.
Justin will come take a look. Yeah. Thanks for asking. We totally want to help make sure people are sticking along with us. So while this is chugging along, I'm going to show an easier way we can run these models and something a bit more practical for you guys. So we're going to just go into this other directory, and I'll go into our magic 8-ball. And we're going to deploy it to the cloud. And so that's free to do. And it's going to give us access to that Fermion serverless AI function. So the command to do that is spin cloud deploy. So it's going to, once you've built your application, bundle all that up and shoot that off to the API, the cloud. For you guys to do that, Justin, there's a question over there. For you guys to do that, you'll just have to log into Fermyon Cloud. It's really easy, just uses a GitHub account to log in, and then there's like a little off loop where you do spin cloud deploy, and it'll ask you to go enter a code into Fermyon Cloud. Okay, so we've got it uploaded now. We're waiting for the application to become ready on cloud. That'll take a couple seconds. Awesome, so we've got it running in cloud, and we'll curl it with the data. Is my cloud demo going to work? Maybe, maybe not. All right, to be determined if this is internet issues or app issues. Wouldn't be a live demo without this, though. Awesome, so this is just the cloud dashboard, and we can use this kind of for debugging here. We'll go into our application, and eventually, perfect. So we can see that that worked, and we got our response back. Not sure why that was so slow. I'm guessing just the conference internet here. And we can see we've got some requests that were made into the app, and eventually some of the logs will propagate through onto here. Although, actually they won't, because we haven't added any logging to our application. So that's how we can deploy the application to cloud, and it will run that. And again, you know, I talked about in the slides, but I want to talk about it a little bit more here, of like what's actually happening when this spin application is running in the cloud and it's making a request to GPU to do an inference. What's happening locally is our SDKs directly look for that Llama 2 chat model, you know, in your .spin/AI models folder and directly execute that. But what's happening in the cloud is it's basically taking this request to do some inference, putting it on a queue, along with like multiplexing that in with all the other applications running in the cloud. And then we have our pool of GPUs that are serving this queue of inferencing requests. And so that's how you're able to have all these warmed up hot GPUs serving your inference requests, but not need to pay for that cold start time of starting up the GPUs and only being paying for that when you're using it. Okay, so that's one way you can do it. Another way you can do it is we have this thing called Spin Cloud GPU, which is a little plugin we built that basically eases local development, so you don't have to run that AI model locally. You can sort of proxy it to a GPU that we're running in our cloud. And so you're still spin up locally, running it locally on your machine, but instead of the SDK saying, hey, I'm going to look for this model locally, it's going to proxy through an application you've put in the cloud and make a request to that. So you're going to say spin cloud init, it's going to create this application in the Fermyon cloud, and then any inference you do locally is going to go through that kind of proxy application. So this is another way you can do it, and I'll just quickly demonstrate this. I've already installed the plugin, but you would just need to run the spin plugins install command. Then you need to go to your application here. I'll turn it off. Oh, and just while we're here, I just want to point out that the local host request we did much earlier, where I said it's going to take forever, did eventually finish, and this is the answer we got from running it locally. This is the answer we got from running it in the cloud, and then I'll show the third option here. So we'll kill the spin up, then we're going to do spin cloud GPU, which is just triggering our plugin. If you just do spin, it will show you all the commands, and you can see cloud GPU is a plugin we have. Spin cloud GPU init. That's going to go through the process of initializing this sort of proxy application in the cloud. Failed to deploy. That's interesting. I wonder what's going on there. Whoops. Perhaps I corrupted my spin cloud GPU plugin. We'll give it the old college debug and try. If you meant to load from registry. Spin cloud GPU help. Interesting. Ah, yes. Question for the group or just need some help? Awesome. Any questions for the group while I try and debug this Spin Cloud GPU plugin? So let's uninstall it and reinstall it and see if that fixes it. Uninstall Cloud GPU. Awesome. Now let's reinstall it. Awesome. There we go. Well, looks like I will have to open an issue in that open source project to see what's going wrong there. Go look at my applications and we should expect to see, come on. Gateway. Looks like I'm having some internet issues here. Anybody have any questions about deploying to the cloud and getting that to work? Do we have anybody yet who's successfully run an inference on the cloud? Not yet. I see people hard and trying. Great question. To really briefly describe why we think WebAssembly makes sense for this kind of functions as a service context, security, you get a sandboxed execution environment, so you don't need to worry about the code people are running, or at least worry as much. Performance, you get like near native execution speed with WebAssembly, while still getting this kind of like polyglot experience where you support all sorts of different languages, and then kind of a portability story, where that's much easier with WebAssembly. A lot more depth to it than that, but that's, I'd say, the TLDR pitch. Okay, well, I'm going to call it here because I'm thinking I'm having internet issues deploying this, and maybe we'll try that in a bit here. I'll move on to the KV thing here and raise your hand if you're getting stuck on the GPU stuff, and Justin will come around and help and make sure you're following along. Great, so we've got the ability to take in a question, generate a response using LLM inference, and that's super easy, but that inference is still expensive. No matter what way you cut it, you're still using a GPU. So it'd be nice if we could cache the responses and every time somebody asks, is my demo going to work? We don't have to say, maybe the internet's not so good. We can cache that response. So how do we do that? You have something to add? No. How do we do that? Spin has a KV function that allows you to write and read from this sort of key value store that's baked into Spin. So the first thing we need to do that is, again, this kind of capabilities-based security. We need to go into the definition of our component in that manifest and say, yes, I give access to a key value store, a default one. So we'll go here. We'll give access to that. Perfect. Just giving access to a default store. Then we want to kind of add this wrapping layer around our answer function, which instead of just directly calling that LLM, it's going to use our Spin SDK to open up a KV store and then grab based off the key, which is the question, and see, well, let me show a TypeScript example. We're going to see, does this question exist in the key value store already? Yes, it does. Okay, great. Go get that value and decode it, and then respond with that instead, with the small caveat that if the response was ask again later, well, we want to try it again to recalculate that answer. Otherwise, okay, we haven't found this key in the key value store. Let's go ahead and generate that answer, store it, and return it. So we can add this, oops, to our app. Get or set answer. Again, we don't have KV imported. We'll import that here. Update the import. Now let's use it. Let's get or set answer. Awesome. And that should work. So if I spin build here, great, successfully built. Again, could test locally, but we'll get the really slow calculation, inference process. So we're going to try and deploy internet pending. Then if that doesn't work, we can try running it locally here. Spin cloud deploy, if your app already exists, is basically just like redeploying and like updating the version of the application. We'll cheat and do both at the same time. We're going to run spin up here. Locally, the key value store is just backed by SQLite on your machine. That's what it actually is under the hood. And we'll curl to the local host. Is this demo going to work? And let's slap a time on there. Whoops. So that we can compare a cached answer versus not. Bad gateway. You want to try deploying on yours? I'm curious if I just don't have internet or if cloud is broken.
Did you finish your init code?
No, so that wasn't working because of the internet. So we're just still using the local one that I have in the .spin AI models. Yep. Awesome. Signs point to yes, but no guarantees. Promising. Okay, and we can see that took 40 seconds there. Switch slow. Okay. I am just going to switch internet networks. Maybe I can just hop on Sheena's hotspot real quick. Penguins. Okay. Now we're going to, this is again running it locally with the model again. And we see that it took 2/100ths of a second because instead of running this really slow 40-second inference on our machine, we're just pulling that answer out of the key value store really quick. Let's just try one more time on the slow network. Looks like that deployed successfully. We'll wait for that to be ready here. When this waiting for application to become ready is running, what that actually means is, so we've taken your WASM binary and we've uploaded into our air quotes cloud, and we're then distributing it across our cluster, so it's on multiple different machines. And so then when a request comes in, it can be routed to any number of machines, and we can spin up your app. And so it's this kind of unique property of WebAssembly as a function as a service that it's not like a Lambda. You don't need to keep a container hot and running to get these low cold start times. You literally just have some WebAssembly on disk, and when a request comes in, you can execute that WebAssembly, and there's still no cold start time, which is one of the cool advantages of WebAssembly. Great. So, oh, I wish I did a time for that. Let's do a slightly different answer so we can compare. Strictly different. So, okay, there we go. About a second, and then if I run it again, we see about a fifth of the time with the caching. Great, so that's in the cloud. Now that my internet's working again, I just want to see if I can demo this cloud GPU. We'll deploy that application. And while that's hopefully deploying, I can just point out the kind of next step in this is, we already understand how to deploy, so we'll skip over that. External DB. So, we're using this kind of built-in key value store baked into the Spin SDK, but we also have support for a number of other external data stores, so like Redis or like SQLite or things like that. So 7 is kind of like an exercise we're leaving to all of you if you want to explore, where, okay, what if instead of using the Spin KV store, I wanted to go to Redis Cloud and spin up a Redis database there and then use that? What would that look like?
Yeah, the nice thing about being able to switch out the KV store on the back end is you don't actually need to do any code changes to be able to do that. You can use the runtime config to just tell the Spin host, hey, I want to use Redis instead of the local SQLite database, which makes it really nice to use when you need to kind of deploy things to different environments. So say you want to develop locally in SQLite, when you go to deploy it to like a Kubernetes cluster or something like that, you want to point it at a Redis key value store. You can also write your own host implementation. I think we have additional ones for, what's the Azure one?
Cosmos DB?
Yeah, Cosmos DB. So yeah, you can kind of swap out the implementation without any code changes.
Totally. So for anybody curious or wants to pursue that, we have all these sample apps here, and under 7 there's some example source code both in TypeScript of Rust of how you might do that. Great. Back to this cloud GPU. Sorry for all the bouncing around with the internet. This is the option that you're running it locally, but you're using this proxy application in the cloud to access these Fermyon Cloud GPU resources. So it's asking us to set up some runtime config. So we'll just do runtime config.toml, paste that in there. And so this is the runtime config that Justin was talking about, where you can switch up the backends. And one of the configurations you can set in this runtime config is, hey, what do I want to use for my underlying LLM compute? And here we're saying we want to use this remote compute. Here's the URL for this Spin app that's in the cloud, and we'll kind of proxy those GPU requests for you. And then an auth token that was automatically generated. So now if I go spin up, and I go runtime config file runtime config.toml. Unable to listen. I have it running somewhere else. We're running locally, but now instead of pointing at that model under .spin AI models, we're pointing at this kind of proxy app, which I will just show quickly here. Fermyon Cloud GPU. That's the app that was generated by Spin Cloud GPU init. We'll make a request to it. So this is locally. Let's just do a new question. How cool is Spin Cloud GPU? And we can see, like 1.2 seconds. So similar times to directly using it in Fermyon Cloud. And again, we would expect the caching. It's like 1/10 the time there. Great. So we got that working. Let's, what's the next step here? So that's the meat of the KV stuff there. I'll stop here for a second. Does anybody have any questions about what we've done so far?
Hi, sir. I came in a little late. When did we integrate the LLM into this Spin application?
Yeah, great question. Yeah, so that was step 3, where we take this, kind of simple JSON API, and then we're now stripping the question out of the request body, and then passing that question off to this function where we generate a prompt for the LLM, hand that to the LLM with the SDK, and generate the response.
We're using the Llama for the LLM.
Correct. And then just the one other notable thing there, of making sure you're defining the capabilities the component needs. Sweet. I'm realizing I skipped the front end step. I knew I was missing something, so let's go back and do that. So a little out of order, that's totally fine though. Let's go add a front end on this. So what we're gonna learn kind of with adding this front end is that, alluding to an earlier question, can I have multiple components in an application of different languages and such? Yes, absolutely. So we're gonna show how that's done. And so what we're gonna be using for the front end is just a static file server component. So it's this pre-built component that we've already compiled to WebAssembly, and it basically knows how to take in requests to what other path it's serving under, and then handle those requests and map those to the files that you have in some sort of like local assets directory. So if I go ahead and use the spin add command, which is basically similar to like spin new, except it's taking an existing application and adding a component to that. So I go into my app here and I say spin add something called file server. That's the name of the component using the static file server template. We want it to map to any path. So by default, it looks for any request coming into static, but in our case, we want to do it under any path. And what directory of assets do we want it to serve up from? We'll use the default of assets. And then, go ahead, Justin.
Yeah, just a note here. Can you open up the spin.toml file?
Yeah.
So now we've got two paths in here, and one is kind of like a wildcard path. So the way that spin interprets that is it will look for the longest match for your URL. So say you gave it /magic8, it'll route to that WASM file first because that's the longest route with the most like URL components in it. And then anything else that it can find for, it'll default to wildcards. So that's kind of how that works without returning 404s for other paths.
Yeah, and that's a great point to bring up the spin.toml here, right? So Justin talked about how there's this new trigger route added to the configuration that's pointing with that wildcard to the file server component. And then you're going to notice this file server component looks different than this magic 8-ball component. The kind of biggest difference is with the magic 8-ball component, we're compiling and building it locally. So the source, we're pointing at some local directory, and then we have a build directive, which is saying, hey, when you run spin build, run this command to compile and produce that WebAssembly at that source location. In the case of the file server, we've already built this WebAssembly component for you and are storing it in GitHub. And so you can just point the source directly to the URL, this kind of like pre-compiled release asset. And then, of course, this is another capabilities-based security option where we're saying, hey, I want to give this component explicit access to files with this kind of mapping from source to destination. So that's the spin.toml. If we go and spin up here and we use the runtime config again, so it's quick, fail to load component, invalid mount source assets. Okay, so it's failing, and that's because I have not yet copied over the assets. So if I just go to the sample app here, copy the assets directory, and then go to my app, whoops, and paste in an assets directory, we should see assets. Great, and we've got it running now. So let's curl it again. Hitting the local point, let's use a new question. How is the weather today? Great, pretty quick, still working there. Now let's see what this front end looks like. So if I navigate to the browser, just on the bare path, it's going to serve up this index.html, which we've got in the assets, and I'll show in a second. And we can ask a question today. Is my lunch going to be tasty? Let's see what it says. Well, Different question. I've been having trouble with quote escaping in the answers by the LLM, so that might be a little debugging adventure we can go on together. Network. Yes, I did. Okay, well, we'll go on a little debugging adventure. Yeah, maybe. So let's start by adding some logging to our app. So this just kind of works like you would expect it to work in a normal application. Let's just see, you know.
Yeah, one thing to note here, something that is being actively worked on in the WebAssembly space is obviously debuggers. You're able to generate debugging symbols, but currently unable to set breakpoints and stuff like that. So something that we're actively working on. Yeah, back to print lines for debugging kind of takes me back.
Yeah. I just actually saw for WASM time, which is the underlying runtime, WebAssembly runtime that Spin uses, that they're making movements in the debugging space, which is really exciting.
Yeah.
And, you know, this is pointing to the future, but WebAssembly gives you so many cool opportunities to innovate in this space. Because you have this WebAssembly module that has these like really clearly defined imports and exports, it makes it really easy to implement things like time travel debugging, because you can, at the interface of this module, what's the word I'm looking for? Know anything that's non-deterministic and be able to track that and kind of be able to do this time travel debugging through there. All right, so we've got some logging now. We're using our runtime config. This is on the local host. How's it going? Okay, well, we're getting our answer. Oh, we're turning some kind of weird bracket on the end. Well, let's see how this works in the cloud. And while we're doing that, I'm going to just show you the assets of what we're actually serving. And so the kind of meat of it is just this HTML file, and we've just got this infer function that whenever you hit enter or hit infer, it's basically pulling that question out of the input box there, making a post request to our magic 8 endpoint, and then waiting for that response, and then inserting that reply. Great, so we've got it deployed. Let's go to the cloud version. How is the weather?
Developer error.
Yeah. Source of the error is between the keyboard and developer network.
I think it's probably in your code.
Yeah, I'm not sure what's up with that. Okay, but so besides the JavaScript not working there in the front end, I think we've demonstrated, you know, kind of the key point of this, which is you're able to compose multiple different components. They can be pre-built, or you can be building them locally to kind of compose this experience together. That's the meat of what we want to present. Now, Justin has kind of a further steps of using SQLite and embedding that. Maybe he can step up here and.
Yeah. Before we go on to that, is anybody having issues getting things running either locally or cloud?
It's probably an obvious question, but do you guys have this whole tutorial up on the web?
Yeah. Do we have the tutorial on the web? Yeah. So github.com/fermion/workshops. That's where you can find all of this. All this information, all the markdown files, code space, and then if you scroll up, This apps directory here is where all of the answers will be. So yeah, there should be answers in there for all of the sections except for the experiment that we're about to go on. Cool.
Do you want to use mine or do you want to plug yours in?
I'll use mine.
Okay.
I think I have some stuff already.
Yeah, looks good. People can see that in the back, or do we need to zoom in a bit? Back. No complaints? Okay, cool.
Okay, so this is kind of like a bonus exercise. We weren't sure exactly how much time we would kind of take up with the first portion, and it looks like we still have an hour and a half. So, yeah, another portion of the Spin SDK.
Yeah, maybe it got shut off.
Mic was off.
Ah.
Yeah, another portion of the Spin SDK, there's another function called generate embeddings. So let's talk about embeddings for a minute. So far we've done some basic kind of text generation, right? Where we've given Llama 2 a prompt to say, here's our question. Contextually, this is what the function that we want you to serve, and here's our question. And that's cool. And one of the kind of trade-offs that we have to make to be able to kind of run all of these inferencing requests across a bunch of different tenants is in order to have that kind of low latency inferencing requests for everybody, we have to use the same model. So there's no like custom models built into Fermyon Cloud. It's all built on top of just the open source like Llama 2 model. And if you wanted to, run custom models, that's something that we're working with a couple of customers on. So yeah, feel free to find my contact information if you wanted to run custom models. But yeah, that's kind of one of the trade-offs that we have to make. So one of the avenues we can take to kind of give Llama 2 more information is we can insert more context into the prompt that we give Llama 2. So how do we kind of do that? We could just dump a bunch of text in there, but then it has to kind of go through and figure out, okay, what piece is relevant. So another thing that we can do is generate an embedding based on a piece of text. So I think the kind of overarching term for this is called retrieval augmented generation, RAG for short. And this is kind of what OpenAI does when you go to chat with ChatGPT. Nowadays you can ask it about current events or websites, and what it does when you ask about that is it will in its database it will generate an embedding based on your question and find other pieces of text that are relevant to your question and include it in its prompt. So the way that this works is that for a given piece of text, you can generate a vector for that piece of text. And it's a 384 dimension vector, so essentially just an array of floats with 384 floats in it. So for like one example, if we were to ask the magic 8-ball, will it rain today? It's going to be a random answer because it has no idea what the forecast is. However, if we were able to kind of give it today's forecast, you know, in like some sort of cron job, just go grab the forecast for the day, generate an embedding for that piece of text. So we can start to give the Llama 2 prompt more information by using embeddings. So the way that we're going to try to do this, and I've built this demo before, but I don't have the code 100% ready right now, so it's going to be a little bit of an adventure, is we'll go through like a list of facts. And then we will generate an embedding vector for each of these facts. And then when we go to post our question to the magic 8-ball, we'll generate another embedding vector, and we'll do a vector similarity search and find the closest vector that is to your question, and then grab that kind of fact and include it into the Llama 2 prompt. It's kind of like a dense piece of information. So do we have any questions so far? Yeah. I'm sorry? Yeah, the embedding vector that we use, so we use the all mini LM L6 v2 embeddings model, and that generates a vector of 384 dimensions, or yeah, just an array of size 384, so 384 elements, and they're all like float 32s. Yeah. Yeah, are those predefined dimensions? To be honest, I'm not entirely sure. I just know at a high level that if I give it this piece of text, it generates a vector, and I can use that to compare similarity to other pieces of text, kind of doing like a search.
This also is in my area of expertise, but I'm pretty sure the embedding dimensions is just baked into the model. So different models might have just different predefined embedding sizes. Yeah.
Cool. All right, well, let's jump into some code. No, you wouldn't be doing that in real time. So you you need to kind of precede like all of these vectors that you want to possibly include in your search. So what we're going to take a look at here is using kind of our built-in SQLite database, which is backed by Terso, and that has the SQLite VSS extension, vector similarity search extension, kind of built in. So we'll store these vectors in a SQLite database, and then we'll use a SQLite query to run a vector similarity search, and it'll kind of rank our most similar vectors.
Just to add some color to that we're talking about what we are building right now in this little demo. You totally could. Hypothetically, you could have a spin application where you have your SQLite database and you have a cron trigger that's triggering an application every hour to go fetch current information, generate embeddings for that, load that into the database, have this separate, endpoint that's serving up these inferences. So not what we're doing right now, but totally is something you could do.
Yeah.
So if we have the code already, maybe a good place to start would be showing them the prompt of how we're going to embed that additional context.
Yeah. So I'm just starting from, I'm kind of working off the answer, so building on what Caleb's done so far. Yeah, so this is kind of our basic answer. Inside of this sys section here.
Maybe just zoom in a bit.
Oh, yep. We're just going to add in a spot for, well, you know, first we need to go through in the process of setting up our kind of SQLite database. So the way that I'm going to do this is using it on Spin Cloud. So I think it's Spin Cloud SQLite. So I've already created a SQLite database. And I can see it here. Yeah, so this will be the database that I want to use here is Magic 8. So the way that you would do this if you're trying to follow along, emphasis on trying. Is you would run this spin cloud SQLite create and give it some name. Yeah. And then we're just going to create kind of a basic table for this. So I think I've already got well, I'll just write it out to a file.
And just while Justin's doing that, I want to remind if anybody's stuck on anything or feel free to raise your hand and I'm happy to come around and help.
Cool. So this is just kind of the basic table that I'm going to create here. And I can do this by running spin cloud SQLite execute. Just make sure I get it right. Yeah. So give it the database name. I just called it Magic 8. And then it wants a statement. So you can either kind of copy paste the kind of text in here, or you can use the @ symbol to tell it what file to use. And that completed successfully. Cool. So kind of like Caleb did earlier, where we gave our Spin app access to Longitude Chat, we're going to give it access to two things here. So we're going to give it access to our AI model called All-Mini LM L6v2, and also the default SQLite database. So just going to paste this one into the Magic 8-ball component. I have a bunch of different Spin demo applications deployed. So I have a default database that's hooked up to other things. You guys probably won't run into this. I'm just going to change this. Does this need to be a label, Caleb, in the Spin toml?
To be honest, I don't know.
That's all right. So I need to link this Magic 8 SQLite database to my Magic 8-ball application. You guys might not have to go through this. I do. Again, if you have any questions on any of this, go ahead and ask Caleb. Cool. So I just had to link that in. SQLite list. Cool. Yeah. So now it shows that my Magic 8-ball app is linked to the Magic 8 database that I created with the default label. There's a bunch of different reasons why we created labels around the databases so that you can kind of create databases and instead of having to like back them up and delete them, you can just link in a new database and then you still have your other one there in case you wanted to swap out. Okay, so going back to kind of our sample code here, we've got our database set up and hooked up to our Magic 8-ball app, and we've given it access to the all mini LM model. And here's some sample code that I wrote to be able to kind of take in a piece of text and generate embeddings for each of the paragraphs. So let's see what that looks like. All right, so we're just going to paste this code in here and fix all our imports. So this is a type that I created earlier. In order to kind of store our embeddings. And then one other thing that I was doing here is just kind of generating an ID for it. Not technically necessary, but going to do it anyways. So we can still use quite a few NPM packages. The only thing that definitely doesn't work is things that have native node dependencies. So it has to kind of compile C. Right now, that doesn't work. But we're working on an update for the SDK where you'll be able to bring in some of the kind of native dependencies there as well. Make sure I haven't made too many mistakes yet. Oh, there we go. Didn't include the types. Great, so that should work. And kind of want like a different endpoint for this, so I think what I'm going to do, is it request dot? I'm just going to hack this in here. If I was doing this a different way, I would probably put it into a different spin component, but for now, this will kind of work. So since I want to use kind of a different path to be able to kind of insert these embeddings into the database, I'm going to add a wildcard to this route, and it should still work. I'm just going to kind of intercept that path here. Again, I'm just kind of hacking this in here for the sake of speed. So ready to insert the data into the database. We're going to see here. I'm pretty sure this is going to give me an error, but nope, didn't need to link in the.
Just while we're waiting for the app to deploy to the cloud here, any other questions for the group, kind of big stuff about WebAssembly or anything we've done today? Be happy to kind of address that for the group.
Yeah, so in the context of this kind of embedding this work we're doing here, I'm curious, are there like canonical sources of facts that you know about that would be used for this kind of application?
Yeah, it kind of depends, and this is where like most people kind of start using things like LangChain, where you can say like I want to use this website as a source of information. So a really typical one is like a knowledge base, like an internal knowledge base for your company, where you can kind of go through and index your like internal blog articles or like documents, like Word documents or whatever. And then LangChain will kind of go through there, split out the text similar to like what we're doing here, save it somewhere in like a vector database and be able to look it up that way. Yeah, so there's a lot of like LangChain examples out there around it. I think the creator of Olama was also on our Discord, and he's also adding support for being able to use Olama and Spin, and being able to do kind of retrieval augmented generation using those APIs as well.
Great
Yeah.
question.
Cool. Yeah, so this is this is again the 384 dimension vector that gets generated. So here's the text. Weather forecast for today shows 80% of rain. This is the kind of embedding vector that gets saved to our SQLite database. So now that we have a fact in there, let's go through and see if we can use it. So the next thing that we need to do is to create a virtual table inside of our SQLite database. So we've inserted that vector into our table, and now we need to create this virtual table in order to perform the vector similarity search. And this is just, just how this SQLite extension works. So I'm just going to create another SQL file, call it reindex. So every time I would go through and create or add in more context there, I would need to go reindex the database. I'm sure there's a more clever way to do it. This is just the way that I found works. Row. Make sure I didn't fudge the database name. Nope. I think it's got to be something with the query. I think the plugins are all enabled by default in cloud. Well, this was working earlier. Let's just point it at. Well, it's fairly anticlimactic that those statements aren't working. I'm obviously doing something wrong. Not sure what it is. Maybe our backing database provider is having an outage. Who knows? Demos, right? So I think that's probably all we have, since can't get this portion of the database query to work. I'll probably post like a fully working example later today to the workshops repo if you guys wanted to check that out. But at least we generated an embedding, so that portion works.
Totally.
You can also do a cosine similarity search in memory if you wanted to kind of query out all of the vectors, load them into memory, and then do the search. Obviously not quite as performant as performing it inside of a vector database, but that is possible too.
We've got about 55 minutes, so we'll be around, happy to answer questions, talk with you guys about spin apps you've been building, do any of that kind of stuff. So thanks for taking the time to attend this workshop.
Yeah.
Great question for our sales engineer.
So we're
Are you, I guess more specifically, are you targeting any particular industries, or is
I'm at 4.
Full.
Test. 1, 2. It is not hot. Test, test. Okay, yeah. brand new wipes, man. For the COVID. Is that Kleenex? No, I could find the Kleenex? No.
Bathroom.
Probably the bathroom is like right after. Oh yeah, there. Yeah, it is. It's like a thing. Yeah. Oh yeah, in the stall. Yeah. No, that's also paperless. You just kind of. Seashells. Yeah, exactly. Yeah, exactly. Seashells. Yeah, it's like from what is that movie? Demolition Man. Yeah. Seashells, man. I don't know.
Nobody can explain that.
Yeah, nobody can explain that.
My wife saw that movie for the first time a few months ago. She's like, what?
Yeah. All right, we're gonna get started pretty soon. While we wait, I think we're still kind of working on something. There are stickers up by the projector there. Little Argo guy, little cutie stickers. So, see here. All right, is it about that time? It's about that time. All right. All right, welcome everyone. Hands-on GitOps workshop using Argo CD and Helm. Otherwise known as stop using kubectl, use Git instead. So this workshop is brought to you by Acuity, creators of the Argo project. So if, in case you didn't know, Acuity is a startup founded by the creators of the Argo project. So to get started here, you'll be certified, introduction to GitOps and Argo CD at the end of this. So if you want to receive certification, go ahead and scan the QR code or else go there on your laptop. I'm going to keep this up for a little while. Also, we do have, marketing didn't actually send us enough swag. So like the first, what do you want to say, 12 people sign up, get something. 20 people first 20 people sign up. We're getting a notification here to get your certification at the end. Also, we have something little special as well for the first 20 people. So I'll leave this up for a few more seconds while I get some water. Also, I'll give you this mic here so you can do your introduction. It's hot. So. What's that? Yeah, I'll send it off to you. Okay. Cool. Looks like everyone took a picture of it and or scanned it. If you haven't, you can come up and get it from me later if you wish here. So we're going to see who we are. So, all right, introductions. So my name is Christian Hernandez. I am actually an Argo CD maintainer. I'm also an Open GitOps maintainer. I am head of community at Acuity here. Again, Acuity created the Argo project long ago inside of Intuit. Also native to Southern California, native to Los Angeles. I actually live in the West Side, but it's my actually first SCaLE. So interesting enough, I lived here all my whole life, but this is my first time here. So I'm excited to check it out. I'm also a guitar player, so any musicians out there want to grab me in the hall, we can nerd out on guitar. And you can find me on the socials, GitHub, X / Twitter. And I'll let Justin here introduce himself.
Hi, I'm Justin, and I am also working at Acuity here with Christian. And today we're going to show you an introduction into Argo CD. If you guys have any questions at the end, feel free to ask. We should have plenty of time. I am also an Argo CD maintainer, and I'm a technical support engineer at Acuity. And I am also local here to Southern California. This will be my 5th SCaLE and my first time presenting. And I've been an avid scuba diver here in Southern California for the last 20 plus years.
Awesome, cool. So I'm going to be running through this workshop presentation. Well, first I'm going to go through a presentation, kind of just get some background, and running through the workshop with you. If you have any questions or running behind or need any help during the workshop, raise your hand. Justin here will help you out. He's actually building out the workshop, updating the workshop as we speak. So I'm going to go through this presentation and then maybe take any questions out of the presentation. So first, I kind of want to gauge, the level of knowledge here. Actually, before we start, the prerequisites. The only prerequisite is you have a GitHub account. We were trying to make it as easy as possible. If you don't have a GitHub account, now's probably the time to start signing up for one. We use dev containers, right? So inside of GitHub, so we try to keep this as self-contained as possible, try not to stress the Wi-Fi too much. The people who did a presentation before us actually said they had some issues with rate limiting and whatnot, so I actually jumped on the slow Wi-Fi. Actually is faster for me, funnily enough. So little trick, I don't know if you're jumping on, it'll make it slow. But so yeah, so anyways, prerequisite, GitHub account, that's really, in a browser, right? Really trying to make it as easy as possible. So show of hands, right? Kubernetes Day, I guess you guys are familiar with containers at the very least. All right, cool, sounds good, good group. Familiar with Kubernetes? Show of hands. All right, awesome, cool. Familiar with GitOps? Okay, a little less, awesome. Argo CD? Okay, cool. We got a good mix here of folks. So a lot of the times it's hard for me to judge because I'm usually like at KubeCon or like at Red Hat Summit or something like that. People are more familiar than a conference like this where it's like a wide range. So we got a good mix here. So let's talk about Kubernetes a little bit. This will probably be review for a lot of you since I saw a lot of hands up there. We're trying to build on why we're using Argo CD, and I always like to start with Kubernetes, right? So from a really basic 10,000-foot view, Kubernetes is a resource orchestrator. It started off as orchestrating containers, right? You have containers, a convenient way to package an application, but there was really no way at the time to orchestrate that across a large environment. And so it started off with containers. It moved on to really being like a resource orchestrator to now, because of the Kubernetes API and the introduction of something called a custom resource definition, you can start orchestrating other things, even other things outside of Kubernetes. If you are interested in things outside of Kubernetes, outside of containers, you can look at things like the Crossplane project, where they're orchestrating things outside of Kubernetes, but using Kubernetes APIs. And Kubernetes is based on something called the promise theory, right? Give me your YAML and I'll make it so, sort of thing. But I think Kelsey Hightower had a really good comparison to kind of like the US Postal Service, right? I have, a letter with a destination, right? Where I want this letter to end up, right? And I give it to the Postal Service, right? I don't have to worry about, planes being delayed. I don't have to worry about trains breaking down. I don't have to worry about like delivery trucks breaking down. That is taken care of for me, right? I don't have to tell them how to get my letter there. It's just, I just tell them what my end state is, right? And really talking about the declarative nature of Kubernetes, which can be done because, containers are immutable. So we really kind of want to describe the end state. I don't want to imperatively say, how to get there. I just want my end state to look like this, right? And how that gets done, I really don't necessarily care about that. And that's Kubernetes. Made up of different controllers, right? Sort of the idea of do one thing, but do it very well, right? There's a controller to scale a pod, right? The pod controller, that's all it does. There's a controller for services. There's a controller for deployments. There's a controller for each individual thing. It does it very well. And it's very loosely coupled, right? Think about things that are loosely coupled in Kubernetes, all based on labels, right? Do one thing, do it very, very well. You can build relationships between those things based on labels. And one of the things about Kubernetes is cloud agnostic. How I interact with, AWS, right, and how I interact with GCP is basically the same. I'm using the Kubernetes API, and the back-end infrastructure doesn't necessarily matter to me. It matters depending on who you are, right? If you're either a developer, you really don't care. Maybe you care a little bit more if you're an operations platform engineer type of thing. But it's cloud agnostic, meaning that it's the same similar APIs no matter where I'm running my workload. So 10,000-foot view Kubernetes, I'm probably saying things you guys probably already know for those who are already familiar with Kubernetes, right? So, so there are some drawbacks to Kubernetes. You're going from a monolith, right? An application. It's like, this is my application. This is, especially for those of you Java folks, it's like you just kind of know, it's like, this is my application, this is my monolith, and I deploy it. And we're going from that to loosely coupled objects, right? Like I mentioned before, it's like, do one thing but do it very well, but your application is actually complicated when it comes down to it. You have a front-end API in a container, and I have a service that is basically my network coming in. Like, well, those things kind of need to come together, right? I need to be able to access, if I have, especially an API, I need to be able to access that API via network somehow, so there's a service attached to that. There's an ingress attached to that. There's storage that's attached to that. There's like all these little different components, and now you got, essentially, Kubernetes is you got like rat droppings really everywhere, right? And you're trying to deploy them and aggregate them together, and it's, if you're running like one cluster, or maybe half dozen cluster, that's kind of okay. But when you start getting more and more into SCaLE and different environments, right? Like you don't just have a production environment, you have different environments, and those environments can have dozens and dozens of clusters, and trying to keep track of all of that is a little difficult, right? And also another thing is that, actually changing the outline, that logo got big, but now we have declarative infrastructure, but people are still managing that imperatively, right? It's like, oh yeah, I'm using Terraform, or I'm using, I'm using, my Ansible, or I'm using this, I'm using that. Like, you're still kind of doing things imperatively with a declarative infrastructure, right? Before, I think someone said like, oh, Kubernetes is kind of like how a system is designed if I took away your SSH keys, but we really traded SSH for kubectl, right? Like there was really no difference there. Okay, I can't SSH into the system, but I'm managing it with kubectl now, and it's really kubectl is an imperative way, an abstract imperative way of managing Kubernetes. And actually now CI/CD became harder, right? CI/CD actually became harder with Kubernetes. Instead of making our lives easier, it made it a little harder because now we're trying to do synchronous tasks. We're trying to meld synchronous tasks and asynchronous tasks together, right? The asynchronous nature of Kubernetes, eventual consistency, but like you have a CI/CD process that like needs to wait for things, but now you're trying to meld the two worlds of, especially if you're going from like VMs to traditional VMs to Kubernetes. Like now it's like, okay, now I'm melding synchronous processes with asynchronous processes, so that now you're going from VMware to reality, right? One of the things that early on in Kubernetes that people seem to not get is like, we come from a VMware world, I guess Broadcom now, where like you have like the VMware cluster, and it's like the central place, and it's like, well, people were trying to treat Kubernetes that way, and it's like, no, actually, you're running multiple Kubernetes clusters, and there's really no central management system for Kubernetes at that time. And so, there was a mind shift there as well. So, so there must be a better way, right? So so now we have, all these little kind of rat dropping objects that you need to manage across multiple Kubernetes clusters, across multiple environments, and so the idea came by of something called Open GitOps. So for those who are interested, OpenGitOps.dev, but Open GitOps was a kind of a work. It started out as a GitOps working group, and it started with members from actually the Argo project, members from the Flux project, members from different, all the big players that you'd expect, Red Hat, AWS, Weaveworks, CodeFresh, Intuit, I'm probably GitHub, I'm probably missing a company, VMware even as well. It's just like all these companies came together. It's like, okay, let's define what GitOps is, because now we have this little thing called GitOps, which is basically managing everything in Git, and then everything else using Git as a source of truth, essentially. And it's like, well, let's define what it means to be GitOps, because we don't want happen to GitOps. Well, what happened to cloud, right? Like really, like everything's cloud now. Like cloud just became, first became like a buzzword, and now it's like everyone calling everything cloud. People calling their local storage cloud, their Plex servers, whatever, right? Oh, that's my cloud. And so we want to define what it means to be, what is GitOps, right? So GitOps, there's 4 principles. If you visit opengitops.dev, there's more information about this, but there's really 4 principles of what GitOps is. And it really stemmed from the fact that we want to leverage the declarative nature of Kubernetes. We want to leverage that, and we want to manage our entire system that way. So instead of managing individual objects with kubectl, we manage it holistically, right? So now you kind of you see the entire infrastructure holistically. And if you're running things declaratively, right? A system managed, I don't usually read off the slides, but I think this is, I usually do when Open GitOps comes up. The GitOps principles is a system managed by GitOps must have its desired state expressed declaratively, right? So no, we want to take advantage of a Kubernetes system, right? Of a system that's declarative by saying, okay, well, like we want to describe everything declaratively. It's version and immutable. Ironically, we don't use Git in Open GitOps, right? Because as long as a system is version immutable, which Git is, but other things are version immutable, like an S3 or object storage, OCI, other things like that, SQLite technically, is version and immutable, but the desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. It's pulled automatically. So I actually personally don't like the wording on this, but open source, you get outvoted. It says pulled out. It has nothing to do with push or pull model. It has nothing to do with that. What it means is that the declarations, software agents automatically pull the desired state declarations from the source. The meaning behind this is webhooks, right? This always this always causes some animosity, especially on Twitter. I'm not against webhooks. You'll definitely use webhooks, even in a GitOps environment. But GitOps says, don't rely solely on webhooks. You're going to use webhooks, and you're going to use an agent to continuously monitor your desired state. So that way, it takes care of things like configuration drift and things like that. You don't have to wait for the next run, or you don't have to wait for some event to happen. It's just continuously monitoring your system, and which then leads into the final principle is this continuously reconciled. So continuously reconciled, meaning that, okay, if I see some sort of divergence, I'm actually going to attempt to reconcile that for you. Software agents continuously observe the actual system state and attempt to apply the desired state. So anytime there's any drift, whether on purpose, whether by accident, whether by whatever means, we want your desired state. That is your source of truth. If it doesn't match that, I'm going to try that, right? And so, interested in attending a meeting, please attend a meeting. OpenGitOps.dev. There's a link there to attend a meeting to find out more. We at OpenGitOps project, we focus specifically on Kubernetes, but we understand that there's entire systems out there that you need to manage in a way. So we actually would want to see, okay, like how can we expand this to include things that are kind of not declarative, right? And so, like VMs, like even mainframes, like whatever, right? Like we need to have some of these principles to expand. So, so that's Open GitOps, and that's GitOps in general. I want to kind of just go over what happens without GitOps, right? Talking about using kubectl. The graphic here, I can go over it, but the main idea behind here is that any part in this scenario can change your cluster, right? Whether it's a developer directly or a developer writing something in a repo, using GitHub Actions or whatever, writing into, changing stuff in the Kubernetes, a container registry, doing a webhook to update something, your CI system, me coming in, doing kubectl, running something. I can change the actual state of the system, what we call an out-of-band change, to the system, whether it's wanted or not wanted, whether it's needed or not needed, whether it's a break glass scenario, doesn't matter. Changes occur in your cluster from anywhere, and you don't really know necessarily know where that change came from, whether whether you do it or not, right? And so with GitOps, there's this kind of little barrier, right? There's this interface, is what I like to call GitOps, is that the interface into your system is Git, because there's a controller. It doesn't matter what changes, right? I can go in kubectl, scale something, right, a deployment, but if it doesn't match the desired state, the GitOps controller will revert it back. And so any changes to the system needs to be done through Git workflows. That's the idea. Whether that workflow is something like a PR, right? That's like, okay, hey, like if I need to make a change to the system, I need to make a PR to the repo, and approvals need to go through place, or whether the CI system creates the PR, or whether whether you make a PR and that then triggers a CI system that changes. The idea is that your interface into the cluster is your source of truth, right? In Git in this case. And so, the GitOps operator has a read-only access to the Git repo, and what it does is essentially just does one thing, does it very simply, right, is it takes your desired state and just makes sure that the running state equals your desired state. And so now, whether it's a developer, whether it's a CI system, a robot, whatever, how I change a system happens through Git, right? And there's best practices and things like that we can go over as we move along. But things like protected branches and things like that, right? Approvals, Git blame, whatever, roll back, roll forward, all of that's done through Git workflows, right? Some of the things that GitOps gives you. Control, right? Like as I said before, all interactions happen via Git, especially if you're using like GitHub or GitLab, Git, right? You have this kind of visual of like who made what change, when, where, why. Collaborations, right? So like if everything's out in the open, how the system changes, how the system behaves is all there. And again, like I said before, you can set up approvals and things like that. From different people is like, okay, only certain people can merge at certain times, that sort of thing. Compliance, right? A lot of people say GitOps is secure. I'm like, well, it helps in security, right? It'll help you along the way. I don't want to necessarily say it's do GitOps and it's secure. I'm like, well, there's other things to take into consideration, but you have a clear audit log of this convenient audit log, especially if you're using Git, of the state of changes of who made what change, why, and you have this kind of like log of like, oh, what happened on this date and on this time? It's like, okay, well, Justin made a change and scaled it up. That's why we're getting charged more, right? So that that sort of thing. And so you can do rollbacks as well, right? Since everything's in Git and you have that convenient history, you can roll back to a certain time. Those are a little trickier, I understand, with GitOps, especially with Git, especially with stateful applications, but you have that ability, right, to see where it was and make the rollbacks a little easier. And disaster recovery. This is probably like my favorite thing, the things that I've done, things that Justin has done as a support engineer is like, okay, well, build up a new cluster, point it to the Git repo, and everything magically works. There's little nuances there, but it actually is as easy as that, right? you may have to do something with storage and permissions, but like it really expedites the disaster recovery process using GitOps. And so that's kind of the things the idea what GitOps gives you and what the whole theory behind GitOps. So again, I'm an open GitOps maintainer, so feel free to go to opengitops.dev, come up to me afterwards. We're going to talk about GitOps and what we're trying to do. And so, so now enter Argo CD. So before I go into Argo CD too much, there was kind of like two main players in the Kubernetes, in the CNCF landscape that came up around the time trying to solve a similar problem, right? I mentioned before at Intuit, our founders at Acuity created the Argo project because Intuit needed a way to on-ramp their developers and their engineers onto Kubernetes. They made a strategic decision to move to Kubernetes and cloud native, and they needed a way to on-ramp the workloads without teaching Kubernetes to developers, right? So they needed a quick way to migrate and to do it in a way that developers doesn't need to know the minutia of Kubernetes. And that's where Argo CD got developed. Around the same time, a company called Weaveworks needed a way to manage their systems effectively, right? At that time, Weaveworks was a managed service provider. They had a lot of products, but internally, they were like, oh, we needed a way to manage our internal system and to recover. And if you ever read a blog about this, Alexis Richardson, former CEO of Weaveworks, has a funny story how it came up where someone fat-figured a config, took down an entire region, right? I'm pretty sure we've all been there. And they recovered it within a half hour, and he asked the question, how do we recover so fast, right? Like usually CEOs get upset when something goes down, but they're like, whoa, that was like fast recovery, why? And they were explaining kind of some of the process they were doing and kind of these tools they were building, and that's where Flux came from, right? And so there was like kind of the two backstories about these tools being developed, trying to implement some of these principles, right, that I just got through with GitOps, right? And so Argo CD. So Argo CD is made up of different components, right? Flux is kind of built as a tool set for like SREs and things like that. Argo CD was really built as a platform. So it's made up of like more components. And so there's something called the application resource, config management tools, applications, application health, app projects. Those things you're going to hear a lot from Argo CD only because they're abstractions from trying to use Kubernetes directly. And so this is actually Argo CD components, right? Oh, that's where that ended up. Anyways, that Argo CD components should be on the top there. But anyways, it's made up of different parts, right? And so the first part is actually the API server. So Argo CD's interface into Argo CD is the API server. So whether you're using the web UI or the CLI, you are interfacing directly with the API server. So you're not really using kubectl at all. You're interacting with Argo CD, and Argo CD does these things on your behalf. And it's at the core, it's made up of a few components, but the main components is the application controller, right? So the application controller, which I'll go deep in a second, is basically an application is an abstraction away from these loosely coupled components. So remember where I was talking about, like, Kubernetes, you have a service, maybe you have an application, simple application, right? You have a service, a deployment, and maybe an ingress, right? But like you want to deploy them together. Well, that's an Argo CD application, right? Argo CD application is basically a collection of these objects, right? It can be as simple as, service deployment ingress or CRD, cron jobs, stateful sets, right? Like you can have, but that's kind of, it's a unit of measure, but basically it's a collection of objects is what an application controller is. what an application in Argo CD is. And then there's the repo server, right? And so repo server is essentially that component. Its only job, and I'll put this as simply as possible, is doing a git clone. That's all it does. So it looks at git, does a git clone, says, is there a change? Oh, there is a change. It notifies the application controller saying, hey, there's a change, you need to apply these new manifests. And that's all the repo server does. So there's that kind of like a separation there of, because that way the application controller has no idea about your credentials or anything like that. All it does is like, it just looks for a change, looks for a notification from the repo server. It's like, hey, there's a change. So that's what the repo server does. There's also connections to like Helm and stuff like that. The repo server does things like it renders a lot of these manifests from like if you're using tools like Customize or Helm. But the idea of the repo server is kind of that separation. It's like all it does, very high level, very simple, git clone. Is there a difference? Yes? Okay. Application controller, do your thing. So. And then there's the application set controller. Someone, I believe you walked up to talk about application sets. That's kind of a little bit more of an advanced topic. But from a high-level application set, all it does is it creates applications, right? So as you can imagine, you can have, your application are made up by different components, right? Simple front-end, back-end, database. And you need a way to kind of like deploy those in a way without creating a manifest for each one of them. An application set controller is essentially a templating engine to create applications. So it's kind of like an application factory is like what I like to call it. You fit it in something, zzz, buzzes and just spits out applications. So it's templating agent, right? And so all these core components interface with the Kube API, right? So Argo CD interfaces directly with the Kube API to do the things it needs to do. It uses a Redis cache for a lot of this. The repo server interfaces with Git. It also does with Helm, but for the most part, it interfaces with Git, so you don't have to connect everything with Git. And then there's Argo CD also includes DEX. So like I said before, Argo CD is a platform, and during the workshop, you'll see why. But DEX, just in case you need to use SSO, right? So Argo CD is a platform. Argo CD allows you to connect, create users, and abstracted users, different from the Kubernetes. You can assign policies and things like that, and a lot of people connect it to, something like GitHub SSO, Google Active Directory, right? Anything that DEX could connect to. So it interfaces with DEX. So these are kind of like the core components of Argo CD, there's other things that come along with it, but these are kind of like the core functionality. There's also like a notification engines. There's rollouts. There's other things to do like a little bit more complex kind of deployments. But this is like the core functionality and from what we are going to do during this workshop. So I mentioned Argo CD application. So Argo CD application, like I said before, is a unit of work. The Argo CD is basically a collection of related manifests, Kubernetes manifests specifically. And the basic principle of it is like you define your source, you define your destination, you define the sync policy. For example, the source is this Git repo. You look at this Git repo, you look at this path, and you're looking at the head, right? Or you can put in whatever branch or tag or whatever, but for the target revision. And the destination, you say this namespace on this Kubernetes cluster, right? So that's where the name comes into place. That could be name or server URL, right? Saying, all right, so this is the source. This is my source, and this destination, I want you to make this alike. And then you have sync policies where it's like if the namespace isn't created, create it for me before I start trying to apply these things. There's other sync policies like retries, auto heal, things like that. We're going to go over those in the workshop, right? You're going to see some of these sync policies in action as well. But it's essentially Argo CD is a CRD that you define your source and destination, your sync policy. One really cool thing about Argo CD, and you'll see this again in the workshop, is that it has a a web UI, right? Essentially, when the folks over at Intuit were creating Argo CD, they heavily focused on the developer experience because, again, that was the problem that we're solving, was developer trying to get their developers onto Kubernetes. So they built a feature-rich web UI, and it gives you things like a top-level health application. So like, at a glance, I want to be able to see the health status of all my resources that are managed by this application. I want to see information about individual components, like a pod, right? Like if the pod is misbehaving, I want to be able to see that, and be able to define custom health checks. And so, like if you have some workload that needs some, song and dance to be able to say if it's healthy or not, all that bubbles up in the web UI. Be able to see it from the interface. It really is, I would argue, the first Kubernetes UI that was out there. Well, the first one that was this feature-rich. And so, at that time, now there's, web UIs, right? Like, I used to work for Red Hat, OpenShift, that was a fantastic UI as well. But this was one of the first UIs that came up, I would say, in Kubernetes, and had all this information, helped with things like triage and things like that. So we're going to see it all in action with the workshop here. So while you're getting your laptops out and getting ready and things like that, I want to pause here for a second and to see if you have any questions. I know I just dumped a bunch of information at you. It was kind of like a brain dump. I introduced a lot of like concepts and things like that. So are there any questions? So there's a question here. Yeah. I'm sorry, can you say it again? Oh, yeah, Mike, 1 second.
Will the slide be available after the workshop?
Oh, yeah. Is there a place to upload them, or we can make it available somewhere? Yeah, we can make it available for sure. Yeah, question?
This might be too deep in the weeds, but I've used Argo CD quite a bit, and your comment earlier. So this might be too deep in the weeds, but I've used Argo CD quite a bit already, and we've been playing around with the operators and trying to do stateful stuff.
Yeah.
And do you guys recommend it for stateful, or we're like pulling out of that? And I'm just wondering, you commented on it, and it feels pretty hard, especially if you're going to move stuff around.
Yeah, it's tricky with stateful workloads with Argo CD, just because it's just tricky with Kubernetes in general, running stateful workloads. But there are tool sets in Argo CD that do things like, are using like things like sync waves, pre-sync hooks, Argo rollouts.
There's doing that as well, but
upgrades are like upgrades a little tricky as well.
Like if you just want to like move things around, it doesn't. You can't like move it between namespaces. I guess that was one issue we had.
Yeah,
and
that's true.
Yeah, it's like a destructive operation. I know it's like it's a limitation of Kubernetes more than Argo CD, but just wondering how you folks handle that, if at all. Is that just like a full migration with downtime?
That is. Do you know, Justin? Like I know you're.
And I'm aware this might not be the appropriate time for a deep level question like this, but I could ask after.
Yeah, no, we can have a conversation. Conversation because like I was gonna say, because it's kind of nuanced. I know we work with customers that do a lot of these things, and there is a lot of like, hand wavy things that you need to do. So, but no, for sure.
Yeah. Thank you.
All right. Any other questions? Questions, comments before we dive right in? No, cool. All right, we're feeling good. All right. So I'm going to pop them in the next slide. I do recommend taking a picture of it, scan the QR code, doing something with it, because there's a lot of information about the workshop on there. And I'm going to be moving back and forth. I'm going to be doing the workshop with you. So whatever issues you run into, I'll run into as well. So, keeps us honest as well about the workshop. Also, Justin is walking around as well, if you have. So there are 2 tabs, technically 3 eventually. We're going to have the workshop instructions are on that link. I'll work with my marketing to get a better slash, because Q02P9, like it's going to. I'm sorry? Oh, the link? Yeah, we tried doing something like that. I don't know. They didn't give us a place to upload the slides, so So yeah, so this is here, scan that QR code or take a picture and type it in URL. I'm gonna leave this here for a little bit. I'm gonna be going back and forth. You're gonna need 2 tabs, right? One is the workshop instructions, and 2 is the workshop platform, right? So Acuity has a platform that manages Argo CD for you. We kind of carved out a training instance, so that way you can have like all the features without signing up for anything. This will take you, the workshop platform should take you to training.acuity.cloud. And so either sign up with your GitHub SSO, Google, or email, whatever. It'll drop you right in. But I'm gonna give it a second to let everyone kind of get this information on the laptop. We should have printed this out. It would have been cool. Yeah.
So what would an unexpected error mean?
Uh-oh.
For the platform?
Oh, that is. So that's a just an error. Let's see if it works for me. I'm gonna do Google. Okay. I did Google authentication. I don't know if you're doing it with the email. You may be running a different. I'm gonna make this a little bigger. So you should see this, and then let me open this in another tab. So let me make this a little bigger as well. So we have the lab instructions on one tab, and the other one. After you log in, let me log out. Kind of go through this process again. So yeah, maybe reload the web page.
Yeah, I'm getting a web page, but I'm thinking it might. Are you on Firefox? I'm on Chrome.
Ironically, I do run Edge as well on my Linux laptop. Anyway, I'm sorry? Yes. So these are the links, and you'll open 2 tabs.
You're connected to SCaLE public cache fast, right?
I am connected to slow, because it's faster, ironically.
Oh, you're just hanging on loading? Yeah, I got the same web page.
It's working? I wonder if it's...
What's that?
But, all right, I'm going to switch tabs really quick. So you should see at least this comes up. And then the other tab, you should be around here. So that's kind of where we are. I'm going to leave also, so I'm going to come back. I'll leave this up for now.
I'm still downloading, actually. I think it's actually the internet that's slow.
Oh, the internet?
Yeah, it looks like I'm downloading over 2 megs of JavaScript.
Oh, fun.
It's really big payload.
Okay.
And I kept refreshing since starting over, basically. There we go. Loading. I know, yeah, no, the same.
So you got it to load? Okay. Yeah, it might be slow-ish. So we haven't gone too far. If you just walked in, we're here in the lab instructions, and the lab platform should look like this. If you're here, feel free to either continue with GitHub, continue with Google, or do a username password for an email. I'll drink some water, because... For what it's worth, I'm using Chrome. Oh, do you? Okay. Okay. Who's still having trouble? Those are zeros, yes. There's a couple people still having issues. It looks like mostly. Someone did mention that it might have been the Wi-Fi because it's. You fish is slow, and yeah. So if like half of you go on slow, half of you stay on fast, maybe. Oh, really?
If you're on fast and you get the white page that's loading, just give it like a full minute. It seems to be a really big JavaScript failure.
Gotta tell Remington about that. Any way to make the JavaScript a little lower? Okay. So have all of you at least gotten the this information? Yes? Okay, cool. I believe, oops, yeah. Okay. So you should be here. There's some cool information if you want to watch the video later, and that's totally fine. I think this is Nick's video. But this, so what we're going to do is it's a little scenario, right? We're using dev containers on GitHub. Again, I mentioned that before, but worth reiterating on GitHub, code spaces. So, when we're on the platform, anytime something's asking about your organization, I'm just going to use my GitHub username. You can name it whatever you'd like. I just call it my GitHub username. We just kind of, to keep it kind of mindless. We're going to be using dev for your environment. So anytime we talk about the environment name or anything like that, we're going to be using the word dev for your environment. Another thing to note, if you already have code spaces running and you're like on a free tier, you may have to like shut down or stop one of your instances for that. I know I've ran into that before. And so yeah. And then we're going to be using a template from GitHub. So make sure when we get to that step on GitHub, when using the template, make sure you use this template. Don't fork it, because the lab won't work if you fork it, right? So like, oh, you can feel free to fork it, but then use this template, right? And so I'll go over how I do that as well. So again, prerequisites. Typically, we say, hey, you should be familiar with Kubernetes, GitOps, Argo CD. We're going to be using the Acuity platform, but we're going to have a test instance of that. And so if you're gonna, again, this is a public website. If you're gonna go home and try it out, I've done this on Kind locally using Docker Desktop. It works just fine. So, first step, right? So let's set up your environment. So there's a link here. It says click this link, and then use this template from this repo, right? And so I'm going to do that. So open this link. It'll let me make this a little bigger. So it'll use this template. Once you click that link, it'll take you to this page. Choose owner. I'm going to choose myself. Repository name is go back to the instructions. It tells you explicitly to use this name. So I'm going to copy and paste this. And again, as Nick, who's not here, couldn't make it. But this is important because the tutorial assumes that you'll be using this name. So it's going to be assumption, right? And so enter that as a repository name. And then click Create Repository. This will create the repo. Basically, it takes that template and creates this repo for you. This will take a little bit. So I'll kind of pause here for a little bit. So where we are in the instructions is we are in the set up your environment. We click this link to use the template. Make sure to name it this. And then we create that'll create the repository for you. So you should be here. So it should see here from your repo. We'll go into that a little later. And we're going to be using this repo, and we're going to be using code spaces from this repo. So this part actually takes a little bit. It'll actually give an opportunity for everyone to catch up because it takes a while to do. But basically, you're going to click the green code button, and you're going to use create code space on main. All right, so I kind of give you the screenshot, and it'll start building the code space for you. So if you click on code, little down space, it might have you here. Just make sure to click the tab where it says code spaces. It says create code space on main. Again, if you're on a free tier and you already have a code space, you may have to shut down to be able to use another code space, but click on create code space with main. This will open up a new tab, and it'll take a little while to load. I think it took about 2 minutes when I did this at home. So just like on my own Wi-Fi. So I don't know, on conference Wi-Fi it may take a little bit longer, but it'll take a while. So kind of leave that up and running. This is kind of where we are. This will give a chance for everyone to catch up if they're still having issues. So, is it real slow? Okay. Yeah, so this will take a minute. So if you're having issues, or if you need a bio break, this will take a while.
Is this using a pre-build, or are you guys building it from scratch?
It doesn't use a pre-build. Basically, we take the Microsoft Ubuntu image and basically run essentially from scratch. So it'll build, yeah. Yes. Okay.
My colleague saw your workshop, I think, last time you did it. So,
Oh, really? Okay. Yeah.
he was in the Bay.
Yeah. I'm actually doing a workshop at KubeCon in Paris. I fly out like in a couple days about Argo rollouts. So I'm actually doing another workshop about Argo rollouts. So when you get to this page, it actually runs a post like install script. So actually give it a minute. Even when you reach this page, there's going to be yet another script that runs. So just give it a little bit more time. I want to make this a little bigger because it's trying to see. So. Yeah, the issue, like this is setting up remote connection. I think it's the connection from here to there, right? There's stuff happening, but it hasn't reached. Oh, really? Oh, interesting. Oh, the email? Okay. Oh, that's interesting. Yeah, because you do like plus, workflow, yeah. Mm-hmm. Now it makes sense why they give us 3 hours for this workshop, because by the time things load. Same, yeah. I always pre-record my demos, because. Rate limiting, yeah. Yeah, yeah. Yeah, exactly.
That's true. Yeah, but if you're going to GitHub to get the servers. This is why you got to use GitLab.
So open a code space, you said, right?
What's that? Yeah, open with code space, yeah. Yeah, so from there, here, a question for those who are catching up. It says create code space on main. So when you click the little code thing, make sure you're on the code spaces tab, and then click create, and then you'll see this screen, and then which then should bring up this screen, there's also posts running scripts. Yeah, I didn't see any other hands raised. I think everyone's, oh, there's someone there has a question. But I think everyone's experiencing the same. Yeah.
We use code spaces every day.
Yeah.
We've done free use, but we've also made it where we're able to like pre-compile and publish that too.
Oh, really?
So we found like a couple actions. I can just point to one of our public repos.
Oh, okay, yeah.
I think it'll work plug and play for yours, but yeah, after
Yeah.
share that with you.
We actually, so usually we run this like locally. We tell people run kind and blah, blah, blah. That just was a nightmare. And we recently switched it to code spaces. So like we just like did this last minute, literally like 2 weeks ago. Like, let's use code spaces. And then like it worked. We're like, okay. Uh-huh.
Literally run the dev container code. So we have a separate repo where we just create our dev container.
Yeah.
And publish that to GHCR. Then from the
Oh.
code space repo,
Yeah.
we just reference the publish our
GHCR, yeah.
On top of that, if we want to run it on our own metal or other cloud,
Yeah.
EC2 or whatever, we could easily do that.
Yeah.
But yeah, it's a simple action. I have to share that with you as well.
So for those of you who just walked in, I recommend taking out a camera, taking a picture of this, workshop's instructions, workshop platform on your laptop if you want to follow along. We're not too far along, so we're just waiting for everyone's code space to come up and running. So. Oh, look at that. Yeah, don't close this tab. This tab is getting it back up is going to be a nightmare. So, yeah. So I think even up here, it actually just runs a little script. I can check. Okay, cool. Yeah. Oh, yeah. Let me put that back up. People are still catching up, so it's cool. A long time, yeah. Yeah, we're good. I haven't actually checked my email because, I'm doing this thing, so. Oh, good for yeah. That's if you have time. Yeah, I mean, or towards the end, or overrides and things like that. Yeah, it's I've used yeah. I use application sets heavily, just because it's just so easy. Yeah, one way of doing things, I guess. Yeah, it's templating. It's so let's standardizing, yeah, standardization is always good here. So if any of you here at least has like a prompt, a few, cool. All right, so there is a post install script that runs, and the most efficient way to check that, if you do K space GE and hit tab, if tab works, that means the post tab completion works with K. So usually I create an alias for K, or you can use kubectl as well. But that is, if you do kind get clusters, you should see dev there. This is very tiny. Let me make this a little bigger. 1 second. Yeah. So here. So it should kind of look like this here. So if you do kind get clusters, it should say dev. And then if you do kubectl get pods -a, you should see something like this, right? So I'll leave this up for a little bit for those who are catching up. So like if you have your dev container up and running, you can run these commands. If you can run these commands and you see something similar output, that means you are right on track and you're running almost ready to start using Argo CD. So how's it? Scale it up a little bit, yeah. Yeah, more scale. Okay, so you see that? Oh, you see them running? Okay, cool. This looks like there's a few of you who are going ahead, which is awesome. That's fine. I'm a little slow to try to make sure everyone's kind of on the same page. So.
I seen the terminal and
Oh,
something.
yeah, that I was there. It takes a while there for there because there's some pre and post scripts that run. That right? So it'll take like a minute or two. So. Oh, it's scary. I considered that too. Well, we don't like refreshing the page, yeah. I mean, the code space does stay up. Like, I mean, you can connect to it later. It's just, you know, you're deciding. So at this point, we should be about here, right? You'll see this page. You'll have your code space, the repo up and running, and you should have this up. So again, how many of you are here? Show of hands, at least here. Okay, cool. I'll have another pause section for those who are trying to catch up. So once you're here, again, if you do kind get clusters, you should see dev, kubectl get pods -A. You should see a very, very tiny Kubernetes cluster. Cool. All right. Again, that's step 3.2. Verify your environment. Make sure things are up and running, right? So now we're actually going to go to the platform, Qt platform. So here, there's some info about actually doing it on the on our actual platform. We have a separate platform separate from our production instance, so you don't have to worry about that. But we're going to go through the similar steps, right? And so here, I am logging in with Google. You can do with GitHub. You can do it with email address, username, password, standard, whatever you choose. I'm going to do it with Google. And again, I think a lot of you came here, right? Again, I struggle with you. Oh no. Yeah. Just trying to get, there we go. All right. How many of you have at least been here or are here? Cool, a little bit? All right. So what we're going to do is, when you're on the Acuity platform, first you have to create an organization before you can do that. So there's a convenient link here. Please create or join our organization. You click that. New organization, I'm going to call mine, again, my GitHub username. You call it foo, whatever. But I use my GitHub username just to, and then once that's created, we're going to create an Argo CD instance here. So here, organization. Yeah, so now we're going to, so now we're about step 7, right? Create Argo CD, click on Argo CD on the left-hand side, and click on create. Here, the instance name, we're going to call it, I believe the instructions say cluster manager, so I'll just do that. We're going to use, you can choose your Argo CD version here. I'm going to use 2.10.1, right, version, because I believe that's the one I tested on, and the little create button, and this will go into progressing state, right? So that's up and running, or going in the process of up and running. This will take also, again, a little while to provision. And so what we're going to do is we're going to, while it's pending the installation, what we're going to do is we're going to set up a user. So we're going to go to settings. We're going to, so once you click on the settings tab, you're going to scroll down on the left-hand side. There's going to be, if it lets me, there we go. The system accounts. So under security and access on the left-hand side, there's system accounts. Oops, I clicked on the wrong one. System accounts. And then we're going to enable the admin account. Click confirm. Set password. I'm going to just generate a password. So I'll do that again, because I did that pretty quick. Click on set password. You can either set your own username and password. That's totally fine. Or you can just generate one. Click on generate, actually sets the password randomly, and you can click copy. And then close it. That actually sets the password to some random string of characters, right? And so if you lose your password or forget it, you just come back here and just reset it. And so, yeah, again, regenerate password, bottom right, set password, hit close. And then it's going to ask you to log into Argo CD. So it might not be up yet. No, not yet. Okay. Yeah. So my gear's a little spinning. Yours probably is too. I'm going to wait. 1, gives everyone a chance to catch up, and 2, gives a chance to for my instance to be up and running. So it might take a little while. Yeah. So if everyone's hitting it at once, yeah, it might take a little bit for this to run here. It actually does give you, what's that? Oh, question? Yeah, so the version I selected was 2.10.1. So that's the one. As long as it's 2.10, it should be fine. That's where the lab was written for 2.10.
Does it make a difference if we use the Acuity build versus I think the open source of the other variant?
There's really no, there's a few differences, but it's mainly like security patches and things like that. You know. Yeah. Acuity specific features, yeah. So usually like there are features there that we're pushing upstream that we release first on our platform. So they'll be on the platform first for our customers before they actually get pushed upstream. So.
But not everything ends up like open source.
Not everything, no. No. So which is we have the different builds. Yeah, question?
I select the upstream Argo CD.
Mm-hmm.
The upstream platform is a little bit different architecturally compared to Argo CD, which makes the push method that syncs stuff and connects to the cluster.
Yeah, so so both ways on the, run on the Acuity platform. So we host it for you, whether you use the Acuity version or whether you use the upstream version. And also for both, we use an agent. Ours is an agent-based design. So we use an agent to communicate back to our platform. Which is the reason why using kind works, is because you don't need to open up API, right? So there's like an agent running kind of to proxy the information, but it's mainly the Acuity version is like CVE patches or little features that we're pushing upstream that haven't landed yet. Authentication, with what respect? Oh, SSO integration, yes, yeah, like authentication, SSO integration, things like that, yeah. Yeah, you do. You can manage it with the Acuity platform, but yeah. So any of you have the green heart? All right, a few of you, okay. And yeah, who has a gear still spinning? Anyone? Okay. Oh, so someone over here does. Okay, gears over there. So once you get this little green heart, there's this little weird UUID type link here. If you click that, it'll drop you into those who have used Argo CD should be familiar with this UI. It drops you in here. Username is admin, and password, you just paste the generated password if it's still in your copy buffer, or if you set your own password, go ahead and enter your password, click sign in, and don't remember that. And you should see this, right? And this is Argo CD. So Argo CD's UI. So yeah, so now you have a fully, okay, so this is kind of where we are. All right, so you should have this repo, right, up in the tab. You should have your dev containers here, up and running, with the information here. The Acuity portal, right, that we use to spin up and self-host Argo CD, and we're using this is the Argo CD UI. So we should all be relatively here. Give it another few minutes for those still waiting on the gear or trying to catch up. What is that? I wonder what screen that is. What's that? Oh, you have, what does it say? No matching applications. Oh, you might have a filter on, actually. I wonder if you have a filter on yours. Oh, interesting. Okay.
But I can still create one like you can.
Yeah. That's interesting. I wonder why it dropped you on that page. Some of you are seeing different pages, like with the little magnifying glass. That should be okay. That's just a different view for whatever reason. I wonder, like, oops, I didn't want to do that. Okay. I messed up. Don't do what I did. Okay. All right, next thing we're going to do is, because, yeah, we're starting to run out of time. Next thing we're going to do, we're going to, we have this kind cluster running inside our dev container, and we're going to add an agent to it, and basically it installs Argo CD for you. So the way to do that is on this page here on the platform. As you may have guessed it, you need to go to your clusters tab. So once you're on your clusters tab, click on connect cluster. So this is very, very important. You need to call the cluster dev. It's basically the same name as the cluster name on kind. Click on connect cluster, and then this will drop this big old thing here that you just copy to the clipboard. Once you copy that to the clipboard, go back to your dev container and just paste it. allow. Okay, yes. And it should kind of look like that, right? It'll look like that. It's some, token, blah, blah, blah. And it'll run those things. Again. Yes, yeah, now everyone is inside now. Yeah. So again, click connect cluster, type make sure to call it dev. That's very important. And then it'll once you do that, it'll have this. You copy that to the clipboard. Once you copy that to the clipboard, paste it, right? You paste that, it'll look kind of like that, and it'll apply all these manifests. What I like to do is I like to run a watch. So let's do watch kubectl get pods -n acuity with a K. So once you run that command, you enter, and you should see the agent up and running and start installing things. Again, kind of like what I went through in the presentation. There is the application controller, there's the Redis server, there's the repo server, kind of the components that I was talking about before, that it's installing it in the on this local cluster here. It does take a little bit to run. You should see, oops, let me close that. Right now it's you should see a question mark because it's trying to add running these containers here. Once this is up and running, it'll send that back to the platform to tell it it's healthy. So that's why I like to run a watch on here. There's a good indication. So how's the platform holding up? Good. All right. All right, let's look at better over than under, I guess. Better ask for. Oh, there's a question down there. Someone has a. Yeah, just in case. Wow. How many of you have gotten here? Okay, cool. All right. Okay, I'll leave this up.
So even though you installed the open source version, it still has a QA agent.
Yeah, the agent, because that's how it. Yeah, exactly. Yeah. Yeah, mine says container creating, so I think it's an issue with code spaces.
Yeah.
Because
your agent's connected.
Yeah, agent's connected. It's just waiting for all the.
Yeah, still.
the health of this guy, the controller, the notifications controller, ironically. Although the init container there is taking a while for the repo server.
Yeah, it's got a down. Well, usually once the agent connects, that'll kick in.
Yeah. We thought cloud was going to solve everything, right? Oh, yeah. Yes, exactly. Yeah, yeah. Throw more computers at it. Yeah, that's what I was trying to. Yeah. Oh, is it TLS search thing? Okay.
What's happening is the disconnected. Download. So once that syncs, it'll bring in all the information.
What shows you all the?
What's that?
Well, I was just trying to see. It does show you all the environment variables.
Try kicking over the application controller. Do a rollout restart of the application controller.
Delete it or roll out?
Roll it out. Rollout restart.
Restart Qt deployment of the which one?
Application controller.
Application. Need a dash controller.
Let's try that.
Okay.
Let's watch the code.
Yeah. Oh, okay. Yeah, gotcha.
That one never came up either, huh?
Yeah. Well, the notifications control. I don't know what's wrong with the notifications.
Yeah, that'll come back later.
Yeah. But the controller. It's just slow, it looks like. What's that?
What's your,
Oh, the ID is, what was that? LK7IL. And go. Let me do the watch. Yeah, so I think it's the get pods. Yes.
Is there anything that I can talk to the conference organizers with that would help you out at this point?
Yeah, yeah, I think it's just the Wi-Fi. It's just slow. Yeah. Yeah. I mean, really, it's. Yeah. I mean, it's understandable. Yeah. Mm-hmm. It is a good problem, though. Yeah.
I'll let them know.
It's like. Yeah, see, be ready for. Yeah. Okay. CK get. Okay. Yeah. All right. Thank you. I appreciate it. Yeah. Failed to watch config map. Interesting. Maybe. I'm thinking. Yeah. I'm gonna try something that drastic here. Not deployments get, but delete. Oh, the syncer pod, the sidecar. Yeah. Gotcha. I heard someone got it further ahead than me. I just might take time. Yeah, I'm a little impatient. Looks like. Also, the sidecar notifies the agent, and then the agent
pulls everything in and all the configs, and then
gotcha.
everything will start.
Well, yeah, we don't have 80 people.
Days are like 30 minutes it's been here.
Oh, really? Oh. Yeah. Well, the syncer.
Well, you got to do
The application controller, and then -C syncer, right?
I don't think you have to do C anymore. You just face it and tab and it should find it.
It just says has prevented get secrets. Refactor failed to watch secrets.
Internal to
Yeah, the client go. Yeah. I think it's maybe trying to, the rate limit reaching out from code spaces. Yeah, it's that syncer pod. It's just vomiting errors.
controller, no errors here.
Yeah, no errors on there. Yeah. Go, 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 go. Has anyone gotten beyond this? No, one person, two. Okay. Yeah, now you're the rabbit. Yeah, you were the turtle. Now, yeah, now you just passed me. What's that? Are they? Oh, you see them there? Okay. Again, if you are past this, feel free to keep going. You're one of the lucky ones. Feel free to keep going with the lab. The instructions are right there, so I'll try to catch up. So when I first tested this, I actually ran into this. Yeah, and I think what was happening is trying to download things that were rate limiting me, like trying to download at that time for whatever reason. I did do something. What I did is I deleted the code space and restarted it, but like that'll take forever here. I'm assuming it is. I'm assuming it's like a rate limiting thing on that.
I think that's the problem.
Yeah. So yeah, there's a sidecar that tries to download a lot of things and then inject that in. I think it's just taking a while to download those TLLs. Yeah.
Once the agent's connected, it connects to the control plane, they sync up, and it pulls all those configurations that are missing.
So yeah, the TLS is missing because it hasn't downloaded it yet. So
Is there any way we can force it? I think it is stuck.
time, yeah, it's just gonna take some time.
Or the install agent, this is separate.
Yeah, so like that's just taking time. That's the step we're in right now.
Just curious, what things that it's downloading, is it TLS?
Yeah, information to connect to the agent. So,
When the agent's connected, it goes to the control plane, pulls the configuration that it needs from the
This
control
is your
plane.
control plane, right? And you
Yes.
From the trading instance, yeah.
Okay, got it. And so those configurations, is it, because I see application controller, Libra server, Redis. I'm just curious, is it like the app projects and everything else?
No, those are all hosted on the control plane, but with our agent-based model and architecture,
Yeah.
basically when you start facing scaling challenges and you have hundreds of clusters,
Yep.
you have an application controller in each cluster so the work's distributed out.
Okay.
So you don't have one application controller crunching for hundreds of clusters. Each
Got it.
cluster gets its own.
Okay.
So it's much more scalable.
yeah, that's what I was thinking. Well, I mean, it's supposed to be every 2 seconds, right? But is yours running at least, or? Yeah. That's a weird error, though. Really? Oops. Wait, really? Oh. Does it use the agent to download the configurations? Or does it go okay.
Agent connects and then it'll sync with that from the
Yeah.
application controller.
But it's through the agent, right? Does it go out on its own?
No, the agent just connects and establishes connection to the control plane.
Oh, okay. Oof. All right. Yeah, go up and do edit as YAML. Yeah, dev, okay. Yeah. Right, done.
That's right.
Yeah, that looks right.
Go to your dev space
Save.
real quick. Oh, no, it's still, this is what we're waiting on.
Okay,
It's not
so
gonna
it
do
can't
anything.
authenticate without.
Yeah.
All those gotta be running. That's the problem. You're doing it right, though. Yeah, RDS is what the deal is.
Yeah, I don't think this will ever kick over, to be honest with you. The agents? I just deleted and reinstalled the agent, so we'll see what happens. So yeah, so I don't know if I made it worse or better, but we'll see. This is the first one doing it this way, yes. We thought it was going to be better, yeah.
I mean, you know, to be honest, when I first started using TypeSpace about 2 years ago, I used to go down so often, so
Oh, so it's, yeah.
at least it's online.
Yeah. We did a different workshop, because we have an advanced workshop, and code spaces work fine there.
I think that's one we call it the advanced one. He showed me a bunch of tricks after that.
Oh, okay, yeah.
So this one's obviously much shorter because it's an all-day workshop.
Yes, yes, that's the one.
Like all the app sets, you go templating.
Yes, yeah, the advanced workshop, and we do that with code spaces, and that works fine, but
For what it's worth, we were using Kind for a while as well,
mhm.
and then we found K3D is just faster.
K3D, yeah, we were actually thinking about switching something lighter weight, right?
What happens is when the agent connects, it's going to communicate the control plane around what configuration, and it'll sync it. And then all that information will get there. We're just waiting for that connection to get established. That wasn't part of that initial install. Yes. Because every cluster will be different.
I was just thinking of that, yeah. Is that what you're doing, K3D?
Try to install my agent.
Does it work?
I know it's Wi-Fi.
Oh, it's just the Wi-Fi, yeah.
Still has the Wi-Fi?
Yeah, I'm trying to install it in a different separate cluster. I think it's the dev spaces, Wi-Fi,
Dev spaces.
or the code spaces.
Code spaces?
Yeah.
GitHub code spaces is rate limiting us?
It sounds, it looks, we don't know, there's something weird because, yeah, because we're using code spaces and like that's separate from this Wi-Fi, right? It's hosted over there.
Put it straight on the Wi-Fi.
So,
So it might be code spaces or the Wi-Fi?
it's a combination of both, but yeah. Depending on where they are, like in the beginning it was the Wi-Fi, but now it seems to be like we're being some rate limiting something weird with code spaces.
Yeah. You're not the first one.
Yeah, yes. The what? Yeah. Yeah. Yeah, his went quicker, yeah. Yeah, still doing container creating. Okay, since we're stuck, what I'm gonna do is, yeah, still same error. What I'm gonna do, I mean, since we're running out of time anyway, yeah, because it's almost 4, right? We're here to 5? Okay, cool. I'm gonna try something drastic.
Everybody's trying something.
Yeah. We'll see. Yeah, bold, yeah, exactly right. I'm just gonna delete it. Maybe it'll be better. Maybe it'll be better if I do it when no one else is doing it.
There's a lot of that. You have, what, 85 people here?
Yeah, about 85, yeah.
In the same data center, but it is likely either Azure or AWS.
Yeah, well, what I think, well, because we're all on the same Wi-Fi, I think like it all's coming, since it's NATed, it's coming from the same IP, so maybe it's some rate limiting, some weird like that, I don't know. But, yeah, but once you're on it, oh, it doesn't really support IPv6? Oh, interesting.
I think only 20% of the internet actually supports it.
Google sees more than 50% IPv6 traffic now.
Oh, interesting.
Who has the most active users?
I found use this tool called Ballroom to help measure latency, like tools like Google Meet and stuff like that. One of the main, I think it's Google Meet in particular, they don't respond to my IPv6 at all. But they do on IPv4. So it feels like there's all it's four
so
stories
hard,
of like
isn't it?
misconfigurations. And no one's really
You never know if they're just pings, but
that's true.
actual traffic is
Yeah.
fine. So, as of February 2024, Google statistics show IPv6 at 39 to 45%. And
Interesting. Cloudflare probably has like a real time metric. And even for that data, you also get a lot of multi-facets, right?
yeah. They have per country adoption.
Cloudflare will give it to you by using from Cloudflare right now. People like US high school, FICA, or like still not.
Yeah, that's what I thought. 72%. So it's about 61. Application path. Adoption and usage. India 76.6.
Okay.
You said 72, right?
That's what it showed here.
Oh, cool. Yeah, I guess Google's got 72 and Cloudflare's got 76. Close enough.
Okay.
Sounds about right.
We don't care.
I think most people are waiting, I think.
The worst part is that even with this machine locked out, you're still not on the internet. It's like 5 to 1. I think it's not like they don't have like everyone to a single IP address, but like it's still, I don't know. Apple has a
Yeah.
/8. It's amazing.
Oh, me switch to SAT and just kind of just show the, yeah, we might be better off switching to a demo. Hold on.
They have some data centers too. Okay, maybe. But like they've had their own /8 since earlier on. Like they didn't get it to do cloud stuff.
I think it only costs $500 here to keep it.
What you have to pay for?
There's like some fees you have to have a side check ASA. I don't think they could take it away from you if you have yet.
Yeah, still running to the same thing. Yeah.
I spun up a new cluster in
Uh-huh.
GKE and it still has that same config map issue.
Oh, really? In GKE? Oh, that's a platform problem. He's running this. He's running in GKE. He says getting the same issue. Yeah. Yeah.
Are they going to put an IP address on all the cars?
They are doing a huge revamp of cars, and they're bringing all the software development in-house. bins and companies doing that kind of things. Because some IT guy said we should buy this, we should get this. It's funny, I was telling my colleague that as well. He showed me just buy some just buy an IDB block before it goes up even more. So what I found is, so I ranked up the same problem. I found two of the cheapest providers. You could go to IOs for $2 for DPS, so you can grab an IPv model, you can do a reverse tele, proxy that somewhere else. Or you could do like sale off AWS for $375. At that point, you get the reliability of AWS with the premium of the last IP, or any other premium. And you can do stacks for free. So you basically get a reserved IP off AWS for $375. So that's where you actually use that for local environment. We do like, you ever use routes? It's like reverse tunnels, expose like your ingress or whatever on Kubernetes, but if you're doing it behind a NAT, kind of like so then you run a VM somewhere, so you like, and in the case for the IP.
What's that?
How are you?
Doing good. Doing good.
We're talking about
So you wrote some scripts because they actually do APIs.
I use Argo CD at work.
Oh,
And when you create an application that creates an
Yeah.
Argo CD resource in the cluster,
yeah.
there's no Argo CD resource or application resource in the downstream cluster.
Yes, correct. Yeah.
It gets created.
So it gets created on the hosted Argo CD platform. Yeah.
Is there a way to look at it, or that's
Is there? Is there like to do like get like kubectl get apps, blah blah blah. No, there isn't. There isn't a way. No.
still trying to wrap my head around the platform. Come back and ask me.
Oh yeah, yeah.
Plenty of time.
No, yeah, we have a.
Are you guys in the right chapter of this?
No. No.
That's one we're easy now. We were easy on this. We have two offices in Portugal. I guess we should just move to the yeah, so those guys, their teams like global, and they're also in school, sounds like you are as well. And they're running around the world. So which version did you go with?
What's that?
Which version did you go with?
Version? I went with 2.10.1, but I think, but AK, yeah, but the AK, the latest AK one.
Default one, right?
Yeah, the default one, yeah.
Previously you went with a different one.
Yeah, I went with a different one. Right now, I'm just testing to see.
I think this is what is working for me.
Oh, really? Oh, interesting.
That's working.
Yeah. So I used the platform, and the agent installed just fine. Yeah, so it's running. Are you? I mean, you try a live upgrade. Okay. So what I ended up doing, if you'd like, you can follow along. But what I ended up doing is I went to acuity.cloud. That is our production instance, right? And so I'm going to be doing, essentially switching to a demo versus a workshop, because it looks like our training instance, there's an issue with the training instance. So it's not, we thought it was code spaces, they were rate limiting us, something like that. We're running some tests. It looks like it is the training instance that we set up. It looks like there's some issues there. So what I'm going to do is I'm going to kind of like switch into a more of a demo, right? So where we left off, or what I left off, is I installed the agent, which is now up and running. It has the Argo CD application controller, the Redis, the repo server, all the stuff that I was explaining to you before, if you can remember that long ago. And so, which is around here, right? And so, what this goes through, and again, if you want to run this, back at home or when you're or maybe on a more stable Wi-Fi with Kind or whatever, this will be up. And what we're going to do is create an application in Argo CD. This is going to be a Helm application. We're going to do, we're going to use the repo that we're in. So, for example, let me, down here, what we're going to do is we have under apps, we have the guestbook application. Let me make this a little smaller. There we go. So basically, an Argo CD application takes a source, and which is the repo that we are working on, and the destination, right? And again, we assume you're using dev as the name, which is why we say that that's important. Here, this is pointed to, say, this repo and in this path, so you can actually see that here. If I click on that, you can see that it is a Helm chart that is stored inside of Argo, stored inside of a Git repo, but you can actually point it directly to a Helm repo. You don't have to install it on Git. Basically, this is the chart, the values file. That's all included in the repo itself. So again, switching back to apps. When we go here, if I click on settings and I click on clusters, it shows that I did add that dev cluster there. I can see that here as well. I can click on new app. I can fill this in using the wizard. Here, it'll ask you all these questions, but you can actually edit as YAML. I could take all this information here. Right, enter it there. Click save and click create. This will actually, what's happening here is the repo server actually went out and did a git clone, right, from the repo against head, and it looks in the path and it says, okay, you want this workload running on this cluster, but is not only are you out of sync, but it's missing. You don't actually have anything there. So if I actually click on this card, it'll tell you that you want a service and you want a deployment. And again, it says the resource is not found. If we go back to this, what is the key combination to get the, there it is, okay. So let's go back up here. If I do get pods, right, it's just the agent, the Acuity agent and the default Kubernetes. So easiest way to click sync here. Let's synchronize that. So what it's doing now is that the application server takes the information from the repo server, says, okay, I'm going to apply this information to my Kubernetes cluster. And if I look back here, if I do get pods, you see, oops, it's actually, you'll see it actually a little easier. You can see that it's actually deploying this Helm chart to the cluster, right? And so it'll give you kind of like an overview here. Let me make this a little smaller so you see. It gives you the application status, right? It's healthy. That health information actually comes from Kubernetes, right? It's taking a look at the health information that Kubernetes bubbles up and displays that. It says it's synced, meaning that your desired state and your running state are the same. The last sync, so the last thing that happened is that it was successful, right? Has information about the Git commit, right? Information about like who authored it, all that stuff here. I can drop into here. I can look at the logs from the UI here. I can look at my endpoint slice service, all that information. I could see that from an overview here, so from the UI. So this is kind of like the idea that Intuit had when they first created this. Like, yeah, we want a platform that I'm able to deploy my workloads and manage them without actually, having to type the Kubernetes command, right? I did all this from the UI, after I have it set up. So, and you'll see this here. One thing I like, I do like to call out is that if I do, I don't think I have Helm installed. If I do Helm ls, right, there's nothing there, right? And you're like, whoa, you installed a Helm chart, but Helm isn't there, right? And so those of you who are not familiar with Argo CD, Alex, actually, one of our co-founders, he says that Argo CD is a glorified kubectl, meaning that I want to manage Kubernetes with raw Kubernetes files, meaning that that whether you use Customize or Helm, what Argo CD does is it renders those manifests, and then it applies them. Long way of saying Argo CD does a Helm template, pipes to kubectl apply. So that's why you don't see that here, and that's a philosophical choice. Is Argo CD wants to work with raw manifests. So if you're working with Argo CD, there's a few kind of advanced users here, but those that haven't been using them or are thinking about using it, just keep that in mind, especially if you're a heavy Helm shop. Argo CD is going to render those for you. If you want them to use the Helm thing, there's things like config management plugins and things like that. You can make Argo CD kind of do that, but the idea, the original creators, is like, we just want to work with raw Kubernetes manifests. So, little sidetrack there, little information about that there. You have a question?
On that
Yeah.
topic, does Argo, does it prefer, but how would you describe the difference between like using a Helm file.yaml
Yeah.
or let's say a chart.yaml in the context of Argo? Does it matter?
Yeah, so with Helm file, yeah, actually with you can do a lot more with Helm file. If you're going to use Helm file, you actually have to tell Argo CD to use Helm file. It doesn't know how to use Helm file. So Argo CD, you have to use something called the CMP, which stands for Config Management Plugin. It'll handle Helm natively. It'll handle Customize. It'll handle natively. It'll even do JSON it natively. But that's it. Like if you need anything else, like if you're using, what are some of these other things? Like there's one from Grafana that does it, and there's another one, Tanami, whatever. There's other ones, right, that is used to render Kubernetes manifests. You have to tell Argo CD how to do that with the config management plugin. So if you want to look that up, config management plugin, Argo CD, you do plug that into your DuckDuckGo or whatever, Google. That's kind of like the information you're going to need there. So, all right. So now changes, right? So syncing changes manually. So let's look at the, instead of running Helm upgrade guestbook, blah, 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 right? You actually, since this is GitOps and GitOps tool, what we want to do is we want to make the change in Git, right? And so we're going to change the image tag. So let's, again, go back down here, and we're going to go to the values file. And I'm going to change this image tag to, let's go 2.0. Right and quit that. I do a git add. Don't do it this way, but I'll do it anyway. Git add, git commit. Something like changed image tag. I git push origin main. Okay, cool. So going back here, let's do, so the reconciliation loop is about every 3 minutes for Argo CD. Completely tunable, right? Some people like it longer, some people like it shorter. Default's 3 minutes. But instead of sitting here waiting 3 minutes, I figured you guys waited long enough. I'm going to click on refresh. What refresh does is that it tells the repo server, hey, go check to see if there's anything new, right? Basically, get ls remote, look at the hash, see if there's a difference. And if it is, it'll download the difference, right? And there's a hard refresh, right? I'll give you a little bit more information. Hard refresh, there's difference. Hard refresh basically does an RM of wherever it get cloned, and then it doesn't get cloned again. Whereas refresh does a get ls remote blah blah blah, right? Just to see if there's a fresh copy. So that's the difference there. As you see here, it says your app is healthy. Again, Kubernetes, you're happy. It may be up and running, but my desired state changed. And it doesn't match the running state. It says out of sync. So by default, Argo CD doesn't set up auto syncing, none of that, right? It leaves it up to you. So in order to get this in sync, we click synchronize. There's different ways to do synchronization, right? There's partial syncs. There's, you can say only sync things that are out of sync, right? There's certain ways to optimize some of this, but by default, it just reapplies everything all at once. And as you see here, replica set changed because the pod updated to a different image. Let me show you something. Again, we're going off script since the platform wasn't working for you guys. I wonder if there's another, let's change the replica count, right? Let's do 2. Should be, if anyone knows a shortcut to just push it real quick. Oops. And then I just kind of want to show refresh.
So you first have to sync, and then if you want to refresh.
You can do a refresh, or wait 3 minutes, or do, yeah, yeah, exactly. Or use a webhook. Again, I was talking about GitOps. It's like you're going to use webhooks because sometimes you want the change to happen immediately after you make a git commit, right? And you'll set up a webhook for Argo CD's API to be like, check now versus waiting 3 minutes, right? But if you click here in the UI, it gives you more information. But what's really cool is that it shows you the live manifests, right? Which is all the, YAML garbage. Click on the desired, right? Again, that's the desired state. If you click on diff, it'll show you the diff. Which is like, it'll show you the inline diff, which is right here. Better way to do that is there's a compact diff that just shows you, instead of the whole thing. So it'll actually show you what that difference is, right? So that's something I forgot to show you. Let me, the next part is, blah, blah, blah. Oh yeah, auto sync and self heal. So this is the auto sync, where is it here? Yeah, so again, I said by default, Argo CD by default sets it up this way, meaning like if there's a change or anything, it'll just notify you. It doesn't really do anything. You have to go in and do that yourself. If you click on details, so let me go here on guestbook. Oops. Details. Down here, we can click enable auto sync. So it says, are you going to enable auto sync? Yes, I am. Self heal. Enable that. Yes. So what self heal does is essentially is like as soon as it detects, as soon as it detects a change, meaning like once the 3 minutes runs and it detects a change, it'll automatically apply those, meaning that it'll do that for you without you having to click that sync button. Prune resources. I always enable this, but be careful with it, meaning that like if someone's at, this is like true GitOps, right? If something's running on the cluster that is not in Git, it'll delete those resources. You may or may not want that. So that's what prune resources is, meaning basically exactly how it is in Git, I want that exact, even if it means deleting things, right? So that's what prune resources means. I always enable it. Self-heal is basically, it'll run the sync, but by default, it won't prune resources. I always just enable it. So this here, actually, I think I need to run a patch. You're seeing some behind the scenes things, so 1 second. Where is my patch? Where did we put the patch? There it is. In order for you to see this working. So this is not, this is something specific to the Qt platform. We made some optimizations, and I revert some of those just so you can see, right? So then let's go here in the lab. Autosync, cool. All right, so let's do another change. So let's go to values. This replica count to 3. Add, commit, push. Okay, again, we're not going to wait the 3 minutes. What I'm going to do is I'm going to click refresh. But this time, as you see, as soon as I click refresh, it notices the change and automatically scales that up. I have 3 pods now. So that I basically didn't have to like sync or do any webhooks or anything like that. As soon as it detected that change, it'll sync those for you. And then I could even go here and then delete this deployment. Just cross our fingers. So as soon as I delete that deployment, Argo CD says, whoa, 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 whoa. You told me you wanted a deployment here. Your desired state says that. Someone deleted this. I'm going to redeploy it. And so, and I can do that with any resource, right? The service here, guest book, delete that service. Argo CD says no, like out of band changes, and that's what autosync, enabling autosync gets you with Argo CD. So. So we did that, and then, okay, so this is kind of so now you see how Argo CD does those things with Kubernetes resources. What's also really cool about Argo CD is that it does these with Kubernetes resources, but Argo CD applications, the application manifest itself is actually a Kubernetes resource as well. And so a lot of practitioners came up with something called an app of apps. So all that is an Argo CD application that deploys other Argo CD applications. And the reason for that is like originally it was for bootstrapping. Bootstrapping, I can just do Argo, kubectl apply my parent application, and all the children, basically all the other applications get deployed that way, including Argo CD managing itself and all of this other resources. So basically, you kind of get a convenient bootstrapping out of the box with Argo CD. You can do other things like someone mentioned like sync waves and things like that. Ordering, you can order things that way as well. So kind of do application dependencies. Actually, if you follow Acuity on Twitter, or if you follow me on Twitter, I actually have a blog that just came out today about application dependencies using Argo CD. And so that's what the app of apps is, right? And so if you look at it here, there's an app of apps definition. What's really cool about app apps, the definition is there's nothing special about it. It's another Argo CD. There's just another Argo CD application, right? It says, this is the repo URL, the one we're using, and the path is apps. If I look under apps here in this directory, you see the guestbook app that we're just using, and there's another app called Portal, also that is there as well. So basically, Argo CD application is going to deploy these 2 applications. So if I go up here with app of apps, and then again, if I just do a new app, edit as YAML, and then I click save here. And actually, let's enable auto sync. Where is that? I think it's down. What's that? Yeah, auto sync for the app. But where is the actually, there we go, sync policy, automatic, self-heal, again, prove resources, just this is how I am. So, so yeah, you notice the, this bootstrap, right? That's the name of the app or the parent application. And that deploys guestbook that's already deployed. So it didn't have to do anything, right? There's no diff, right? The desired state and the running state, there was nothing, so it hadn't had to do anything. But then it created this other application called Portal, right? This one isn't set up for auto-sync, and so I have to, sync this manually. So then that deploys that as well. So, so what's really cool about this is let's just delete guestbook, just delete the application. You notice the Bootstrap app noticed that it was missing. If I go here, it noticed that other application was missing. And so, so let's sync that. And then, magically, guestbook comes back. So like you can see that if I delete this app, guestbook, delete that app, that's gone. If I sync so that's it. You can kind of see that like how you can use Argo CD to kind of manage other Argo CD components, having Argo CD manage itself. By using something we call app of apps pattern, right? And so that is what most people used it for. There's a question? Yeah. So deploy changes to the apps individually, meaning? Yeah, yeah. So you can still change things in the guest book individually, right? So the app of apps, all it does is just make sure your application definitions are there. You can still manage those other ones individually. There's certain things that it doesn't allow you to do, right? So like if I do, there's certain caveats. Right, okay, cool. So that's auto sync. So like if I go to guestbook here and if I do enable auto sync and then enable self-heal, this just enable all of this here. Since I have an app of apps running, if I sync this, and then I go back to guestbook, these things should be, oh wait, I think I disabled that. I think I did, yeah. Okay, normally what would happen, I actually wanted to error out and it didn't. The one time I wanted to error out is because I didn't set up auto sync here. If I set it up in the UI, the parent app will overwrite that. Because now my applications, instead of being defined in the UI, they're defined in Git. Really, that's really the only thing you need to look out for. It's like, oh, the UI isn't doing things. It's like it doesn't write back to Git. It just does whatever Git does. So, if you're managing things with app of apps, you really have to go really all in on GitOps because it's like now you have to manage. Now you have to think, well, now I'm managing things via Git. And the UI mainly becomes like a visualization, observation type of thing. And mentioning that, ironically, or I guess on that same note, Argo CD ranks number 3 in observability tools, which is really funny because it's like they didn't really build it as an observability tool. But it does rank number 3, like number 3 or number 4 in the CNCF of observability tools, only because once everyone's all into GitOps and managing these in Git, it actually does become more of an observation read-only thing than anything else. So, so as far as the workshop, that's the workshop in its entirety. We still have some time if those who are still trying to get it up and running. Justin is trying to get the training instance back up, but are there any other lingering questions? Look, I saw someone's hand up there. Yeah, you. The reconciliation loop? The default is 3 minutes. 3 minutes, yeah, and you can again adjust that for whatever makes sense to you. Some people turn it off. There's something called, and you just use webhooks, which is fine. It's not GitOps, but I mean, not everyone's going to adopt that, so that makes sense. Argo CD is flexible enough. There's also what we call sync windows, meaning like, oh, I only want the sync people to be able to, whether it be people, APIs, robots, whatever, to be able to sync certain amount in a certain amount of time, right? Like off hours, right? Like I don't want a sync to happen during on hours and off hours, but that's so that's completely adjustable. It's 3 minutes, but I set it to 5 seconds for the demo. Yeah. Any other questions? There was right here, glasses. Yeah. Yes, for Argo CD, but that's you kind of have to hunt for that a little bit. If you're using Acuity, we do keep a history of, this is going to take a little while to bubble up, but we do keep a history of what, if you're using the platform, but this data comes from Argo CD itself. You just kind of have to look in the logs for things like that, yeah.
There's actually a dashboard, so if you enable the service monitor in the free open source Argo.
Oh, yes, yeah.
Prometheus stack or whatever, like you have Grafana and Prometheus installed. There's a Grafana dashboard.
Yeah, so yes.
It's well maintained, but and I don't know how to read half the charts.
Yeah, yeah. There's like a Grafana. There's something you can enable and point it to like a Grafana dashboard or something, so that way it'll populate that for you. Yeah. Service monitor is what it's called. Yeah. Actually, I should probably install some of these plugins so you can see. Yeah. Okay, yeah, any other questions? I saw you in the back, yeah. Yeah, so the question was about application dependencies if they're already up and running and you want to do an upgrade. How can, can you make them dependent on each other? So, and again, shameless plug, I did write about this in my blog, but there is methods to, there's no native way to say this application is dependent on this application in Argo CD. There's no native way. So one of the ways, but you can still do it, but one of the ways with Argo CD is to use sync phases and sync waves, right? So sync phases or sync hooks is like you can have like a pre-sync tasks. You can have the sync task, which is what we're watching now, and a post-sync task. So and they go in that order, right? Pre-sync, sync, post-sync. On top of that, you can do sync waves, meaning like in each individual hook or phase. So let's say like you can say, you can annotate your resource with saying, 1, 2, 3, 4, meaning like basically lower level, and you could actually do negative numbers, but lower means higher priority. So, and usually people do that like with like CRDs, right? Like I want to deploy a CRD first, and then the CR, and then other things, or I want the storage to be available before blah blah blah, right? So that's kind of like the background, because then since you're using app of apps, right? You can have dependencies that way as well, because you can annotate your applications, right? So you have the parent app controlling, and it'll honor sync waves. So you can say, all right, database gets sync wave of 1, my back end gets a sync wave of 2, and my front end gets a sync wave of 3. So when I sync the parent app, it'll respect that. It'll basically it'll sync the first one, wait until it's fully synced, and then it'll move on to the next one. So that's kind of how you get it from using the app of apps. So that's only possible with app of apps. Yeah, so application set, and again, like from a high level, application sets are a templating engine. So application sets, a stable version, no. So in application sets, there is an alpha feature called progressive syncs that that does what you're describing. There's a big capital C caveats because there's like things that happen, like it turns off, it disables autosync for you. Like even if you have it enabled, it'll just disable it because it relies on the application set controller's logic to do the syncs. It won't let you do like autosync or anything like that because it'll just rely on the upper ones. But you can use progressive syncs. I've used progressive syncs. And between us and I guess whoever's watching the recording, I know Intuit does use it in production internally, but it's still technically alpha. I've actually brought this up in the community meetings. It's like no one's complaining about this feature, so either no one's using it or they're using it and there's no problems. We should probably move it on to like beta, but it is still alpha, so that's really the. No, the progressive sync logic will sync them for you in that regular interval. So you would have to either wait the 3 minutes or use a webhook if something happens. Yeah. All right. Any other questions? Yeah. Question. Yeah. People are still using both, and just from like my experience, well, one, my opinion, and because of the experiences I've been using with our customers, is that you're going to be using both for different things, and you might be using them together. So I know, yeah. Yeah, so I've seen folks use like app sets. So like they have like a parent app, kind of like the Bootstrap here, and that deploys application sets, right? And then I've seen the reverse where I've seen the application sets, all it's doing is deploying other Argo CD apps. Yes. I've seen that, and yeah. Well, for the one I'm thinking about, is like there's a project called the GitOps Bridge. Is that basically they want to be able to deploy application sets massively because there's going to be an application set per like environment, for example, and they just needed a way to deploy it using one manifest, right? So they'll use an app of app sets. Yeah, application set per repository, or like there's just certain boundaries, right? Because like, there are places that are still kind of like siloed, or they want to build like these gating, type of things where, like I have an application set, but I don't want like any this is my dev application set and for all my dev clusters, and this is my tests, and this is my prod, just because they want that separation, and they may have different repos for different things. So. There really is different use cases, right? There's like, and there is, and people do that. I mean, I would do that. I recommend that. It's still kind of hard to get people's mindset changed away from like, because there's like a Git workflows, right? So like all the separation of everything happens in Git, right? Your repositories, like no one has access to anything, right? Like at some point, even the administrators really don't have access to a lot of the stuff, and they use Git as the interface. But that's like people who are really far into it. There's still some people that need, and there's some regulations, right? There's still some compliance things where like I need the separation of, there's like, certain things there might be just like compliance, right? Like HIPAA compliance and, governments, Yeah, there's.
Even though you're exposed to it, you don't think
Correct, yeah, yeah. There's little nuances in, from every industry and, people, how you operate like something like in, medical, right? Like HIPAA compliance are very, very strict. Banking, right? Like banking, like Swift, yeah, banking, Swift, like all like there's very different regulations to where even though you can do it, like in one repo with one application set, there may be regulations that won't let them. That's another way. So it's a combination of all those things. Yeah. All right. Any other questions? Yep.
I noticed that you installed the Acuity audit log. I was just curious on what that looks like.
Oh, the Acuity audit log. Yeah, I did. I may have to like generate like some things, right? Right. I need to like generate some noise. Yeah. So this is a plugin specific to the Acuity platform. So when you look at your applications, like let's say Bootstrap, and then I click on the information. There's new tabs now. Audit logs, right? Like who did what, when. Based on the user that you're logged in. So if this is like connected to SSO.
Work with like, if I do, because I think there's like an exec feature, does it actually say who logged in? I assume? Like if you have
I actually don't know if the exec, I don't know if it captures that actually. And the sync history, like who did what, when, kind of Celadora-ish metrics. And like if I was logged in like with SSO, instead of saying admin, it would have like my username, right? Yeah, so this is specific for this. Like if you have multiple, like because with Acuity you can have multiple Argo CD instances, and then it gives the which one? Do you?
The very bottom. Oh,
application metrics. Yeah.
So you don't make your font anymore, or is that going to replace it?
That I don't know. I don't know what application metrics is. Do you?
It's not a replacement. You still have to have Grafana and Prometheus stack installed, but if you were to install that, it's just an add-on, then you get the metrics natively in the UI.
Yeah, natively here, like in the UI. And then there's like the AI assistant, just because everyone.
Yeah, it's definitely better to have access for sure. Just put it in there.
So if I go here and I say, again, why is this missing? Who knows? I actually didn't prepare it. In the health field indicates application is missing from the target environment. It means blah, 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 blah. We actually do have a customer that's saying that this has reduced his calls from his developers. So for what it's worth, I don't know about the AI train. This is pretty useful because I know when I manage systems, I used to have devs that needed complete handholding and devs that I never heard from. So I understand the noisy developer thing, and this actually has helped that customer. So it is kind of cool to have some of these plugins from the Qt platform. So cool. Any other info? Comments? Yeah, it's an AI plugin. Yeah, yeah. Yeah, more educational, or like more kind of like yeah, or like kind of just like instead of picking up the phone calling the IT guy, the developers that kind of like are using the AI assistant to help them debug some of this triage things. So, and I think it uses. I know it doesn't use. It uses publicly available data from like the Kubernetes logs that people have posted, right? So it actually doesn't use customer data. So it doesn't like learn from your, right? It just kind of uses publicly available information. So kind of stuff that you should already know, but like there's people that don't know, right? So. What's that? Here? No. Yeah, no, I know. We have, yeah, well, a lot of us are flying to KubeCon, so I know I'm flying Saturday, so a lot of the team is there, so. Cool. Yeah, any other questions? Comments? Yeah. Yeah, so that's going to the application set. So the application set comes with a lot of generators, right? So when we talked about, and I may actually pull up the docs Argo CD, CD dot read the docs. Okay. Let me make this here. If I can, we were actually just talking about how we hate our docs, but operator manual, application set. So application set, as I explained before, is basically a templating agent, right? Like it just basically takes input and then it turns it into an Argo CD application. So the templating engine is based on things called generators, meaning like how do I generate this template, right? And there's different generators. First, there's like a list generator, right, which is basically basic key value pairs, right? Foo equals bar, blah, 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 right? And you can use that to build your Argo CD application. There's a cluster generator, meaning like based on cluster information, I want to build my application that way, right? For example, it says like, where is it? Yeah, the secret here. It's based on the cluster secret, right? So I can say based on if you are a cluster named foo, I want you to deploy this application. If you're a cluster named bar, deploy this application. You can any labels that you add, right? Environment equals dev, right? Any cluster that's labeled that way is going to get that workload. So there's a lot of those generators. Let me see if I can find, there's a get generator, matrix generator, but there's also a pull request generator, right? Which is what you're asking about. So since we're doing GitOps, right? In order to see something in your environment, you have to merge your pull requests. A lot of people don't want to do that, right? A lot of people say, well, I want to see how it looks like before I merge this. And that's what the pull request generator is. It basically looks at your pull requests and saying anytime, there's a good, there we go. Anytime someone has a pull request and labels it preview, I'm going to deploy that into an environment for you. With Argo CD, you would use an application set and you'd use a pull request generator to say, okay, so anytime there's a pull request on this repo that is labeled a certain way, I'm going to deploy that workload. As soon as you merge it, that pull request goes away, and Argo CD will delete that environment for you. So that's kind of like how, there's a lot of nuances on how it works, but basically that's from a high level, that's how it works, and that's how people are kind of like previewing environments. Yeah. All right. Any other questions? Comments? So again, sorry about the platform. The platform, it was actually ended up being a platform issue. We just discovered it too late. We burned a lot of time trying to debug. Again, you can do this workshop. If you have the link, the scenario is up and running. And then we have our production platform if you want to sign up, test it out, kick the tires a little bit. So, all right. Thank you. Again, Christian, Justin will be around this weekend, the conference. So yeah. What's that? Oh yeah, the email. Do you have an email?
I'm pulling it up right now.
You're pulling up email.
Christian,
Yeah.
I have two questions for you. One on the apps.
Yeah.